going? It's so nice to finally have this live stream, and I hope you all get to enjoy this live stream. So, a quick introduction about myself. I am Ace, popularly known as Ace in the community. Well, I'm Aziz by real name, and I'm so excited to be here live with you all. So I love AsyncAPI. I live and breathe AsyncAPI, and I hope you all get to like enjoy this session. So a little bit introduction about what we are gonna do today, right? So we are going to be building a real-time collaborative drawing application using AsyncAPI and WebSocket. So that's it, people. That's what we're going to be doing, right? So before we get right into it, I'm just going to ensure like we are live. So if you are currently live with me, feel free to say your name and where you are joining me from. So I'm just going to quickly confirm if we are streaming to YouTube also. Um, Cool. So we are streaming to YouTube. Everything is working perfectly as expected, right? The reason why it's working perfectly is okay. I think I have it. Okay. Akshat, thanks for the camera thing. I don't know why. I'm always having trouble with Restream. Anytime I'm using Restream with my main camera, I don't know for some reason. Actually, so I don't think I can fix it at the moment. It's not me. It's just Restream. Sometimes it's okay. Sometimes it doesn't work. But I'm glad it's even showing right. Sometimes it doesn't even see my camera at all. But now it's having this whole focus issue. So please just bear with me, and I promise during the next live stream, I'm going to try to, make sure this doesn't happen because this is the first of many of these live streams I'm gonna be doing, which is basically going to focus on so many use cases of async API with different communication protocols, ranging from WebSocket to Kafka to MQTT and so on and so forth, right? So, and I hope I am also audible. My audio is clear. Um, so, can you confirm if my audio is also clear, Akshat? Thanks for joining. So, yeah, let's get started, right? So WebSocket, we all know like what WebSocket is and why we use WebSocket because of the ability to do real-time communication. Unlike HTTP or REST, like you all know it, where you have to, poll before you can get a response, which basically means the client has to make a request to the server before the server can then give the client a response. So I mean, that is also known as HTTP polling, which I'm not a big fan of. I mean, I'm going to do a video why I mentioned I'm not a big fan of HTTP polling and how it is not actually suitable for the environment. Right? I know you're like, oh wait, Ace, what do you mean? So today is not about HTTP. Today is like for WebSocket. So unlike HTTP, WebSocket doesn't. Allow you to do all this polling stuff, right? So basically, what WebSocket does is WebSocket keeps an open communication between the client and the server. So the client doesn't have to like request some information from the server before the server can send information. So the server can easily send data to the client without the client requesting for it first. And that's basically possible because of the open communication WebSocket allows your client and server to have, right? So drawing, right? Collaborative drawing. That's what we're doing today. So let's just quickly get started. Let's see. So I mean, we don't want to just get into coding, right? We need to understand what we are trying to build. And also for the sake of this live stream, I've actually did some drawing. Some architectural drawing for the application we are trying to build. So let's look at some of these drawings so we can know the kind of decision we are making while building this application. So I'm gonna pull up my screen real quick. Okay. So yeah, so this is what we could be doing, right? So I know my drawing looks really weird. I try to make it as clear as possible, but I believe with more practice, I'm gonna be really good at doing this whole API architectural drawings. So just manage with me with this. So what you are currently looking at is the architecture of the application we are trying to build, right? So you're gonna see we have this client, we have another client, we have the server, and we have a sync API, right? So what we are trying to do is we want our clients, which is to initialize a connection to our WebSocket server, right? And what basically that means is when we initialize a connection, which means when our client, I mean, this looks really bad, right? Because I also didn't do a lot of grouping. So when I'm moving this client around, you can see the whole like component and I'm moving with it. So we're just going to use it like that, right, today. So basically what we are trying to do is say, so when a client initializes a connection or when a client is trying to create a connection or to connect with our WebSocket stuff, so the client creates the connection with the client's username and the color. And the reason why we are using the username and color is because we are building a collaborative drawing application. And then we don't want every single client that connects to our application to have the same color of pen while drawing, right? So that is why we are specifying color. So immediately a client is trying to connect to our WebSocket server, we need to get a color assigned to each client, right? So when a client is connecting, the client has to provide their username and the color that will be assigned to them, right? So because it's a collaborative drawing, we want all that client to see different colors of drawing on the canvas, right? So basically different color represents different users. So when a client is initializing a connection to our WebSocket server, the connection has to be made with this payload, right? With the username and the color. And we're basically using it to authorize the client. So if you did not provide this username and color when trying to connect to our WebSocket server, it won't work, right? Because it is required. So that's like the first part of this connection. You can see this overflow connection initialization. We pass down this payload to our WebSocket server, and then our WebSocket server basically just does its things, right? It authorizes the user. So if the payload or the schema or the data the client is sending, which is the username and the color is valid, then we are going to initialize a connection, right? We're going to connect this new client to our WebSocket server. So the second part of this whole thing is this message, right? So when a client connects to our WebSocket server, when a connection has been initialized, the next thing we want to do is, of course, exchange data, right? So we want our client to be able to send messages to other clients, right? And we have two types of messages in this our application, right? So because we are building a collaborative drawing app, which means we have to be able to altogether draw on the canvas, but also we should be able to chat with each other, right? I mean, WebSocket gives us this flexibility to do whatever it is we want to do, right? Being able to like send whatever kind of messages we want to do, send, or whatever data we want to exchange, because there's an open connection, right? We can just send any kind of message typically, or any kind of data typically. But for our application, we want to be able to exchange two types of data, the drawing data and the chat data, right? And that's why you can see I use this green color as to represent the messages being exchanged in our WebSockets communication. So we have the client should be able to send these types of data, right? Either a message drawing or a chat message, right? Or a drawing message or a chat message, right? So we have to send these our message, the message the client is sending has to be one of these two. So when the client sends this message, let's say the client is sending a drawing message or a chat message to the WebSocket server, the server should be able to then broadcast this message to the rest of the client, right? Which is basically how most of our group chats work, right? So when you send a message to a group, everyone that is on the group gets the message instantly, and that's what we are trying to do. So whenever a client sends a message, we want the rest of the connected client to receive the message, right? So when a client sends this message, either type of drawing or charts, one before we broadcast the message, you can see we have async API, right? And I know I haven't mentioned anything about async API. So we have async API here. But what we are using async API to do in our application isn't just to document our WebSocket API, right? We are also using async API to do two extra things, which is to validate our message and also validate our schema, our authorization schema here. So we're going to go into that shortly when we are writing our AsyncAPI our AsyncAPI document. So let's continue on the diagram to understand how what we are doing works, right? So when we send this message and either of these two to our WebSocket server, so what happens is our WebSocket server then take the message and then validate it against our AsyncAPI definition, our AsyncAPI message, our AsyncAPI schema definition, right? So we take this message, we send it to the server then validates it, and then you can see then we have two different arrows, right? So I use 3D colors to make things easier to follow. So we have this green one, which means successful. I mean, of course, green means when something is working, and then red means something is wrong, right? An error. So when we send data to our WebSocket server, and the server, our WebSocket server then validates the data against our async API, and then says, oh, so this data sending to us, is it a valid data, right? Is that the kind of data we are expecting? So if it is the kind of data we are expecting, then we are going to send, so if it is kind of we are going to then broadcast this message. See, I mean, I could have easily done it this way. So like this, but what I'm trying to do here is saying, okay, so when our WebSocket server sends this data to async API, or AsyncAPI document, and then validate it against our AsyncAPI document and says it's a valid data or a valid message. So of course we get a response, and then after getting a response, we then send this same data, then we broadcast it to the rest of the client, right? So, but if it is not the kind of data or the kind of message we are expecting from the client, so we are taking this. That's why I'm using this red arrow. So once we validate it against our schema, so once we validate it against our schema here, so we then send, instead of broadcasting the message, of course, why would we broadcast it? Because of course you are sending the kind of message we are not expecting, right? So we are then going to send you a response saying, oh, you sent the wrong kind of data. So this is not the kind of message we are expecting you to send. So the client gets an error back, right? So that is basically the whole, architecture of what we are trying to implement, and how we are going to use the Sync API, not just to document our API, but also to use it to validate our messages, right? To ensure we are getting the correct messages. So a better diagram, a better flow that I did, of course, I love colors, and that's why I'm trying to make all of this colorful, would be this one I have here, right? So I don't know how I did a lot of drawing for this stream. So, so a simple Mami diagram of what we are trying to do here. So we have two clients, right? We have the user A, we have user B, and when user A tries to connect to our WebSocket server, the WebSocket server does some sort of authorization. For this use case, we're not going to be doing some really complex authorization. We're just going to be validating the kind of data being sent from our client against our AsyncAPI document, right? So the client tries to connect via WebSocket, and once a request hits our WebSocket server, we validate the username and the string, username and color against our AsyncAPI document to ensure it matches the type of data we are expecting for our authorization payload. So if it is valid, then we acknowledge the connection, right? We send it back. Okay, yeah, connection initialized, right? So this is what is happening. You can see, and then the same thing happens for user B, right? Create a connection, acknowledge connection. Then user A send drawing action or drawing data. We take this data. So when user A sends this data back to tries to broadcast a message or a drawing on the canvas to the rest of the connected client. We send the drawing data to our WebSocket server, and then our WebSocket server then validates the message, like I mentioned earlier, against our AsyncAPI definition, right? So if it is valid, it's gonna then broadcast the message back to user B. You can see, right? So user A sends message to WebSocket server, then WebSocket server validates this message against our defined AsyncAPI schema, and then if it is valid, then our WebSocket server then broadcasts back to user B, right? So you see, we are not broadcasting back to user A, right? We are broadcasting back to user B, and you're gonna see how we're gonna implement that. And then and so on and so forth, right? The same thing happens for user B, and user A also gets data if it is valid. And then we connect, we disconnect, the whole basic WebSocket connection instance. So that is basically like the whole thing, the whole architecture of our WebSocket connection. So if you have any questions, please feel free to drop. So while we wait for questions, the next thing we want to do now is write a WebSocket specification, WebSocket document, which is like the exciting part, right? So I know a lot of people want to start writing code, but I'm a huge fan of designing my API first, right? And the whole advantage of designing your API first is because it gives you this clarification of what you want your API to do, right? So it also makes your API development faster, right? It gives you this concise clarification. So you don't have to like start writing your WebSocket API, and then you're saying, okay, what kind of data are we expecting? Then you go back and forth, and this whole thing just takes time, right? But if we design our API first, we don't have to do all of that, and you're gonna see the advantage of designing our API first, which is also I don't know if you've heard about this whole terminology or methodology called API first or spec first. And that's what we're going to be doing. We're going to be writing our specification first before actually implementing our API, right? And I just mentioned one of the some advantages of doing this first, and also it also brings all your stakeholders like on board to actually get a good understanding of how the API is going to work, which is going to save you a lot of time, right? So the next thing I want to do now is to start writing our API specification or our AsyncAPI document. And to do that, we are going to use one of the AsyncAPI's amazing tools called Studio. So you just have to go to studio.asyncAPI.com. I'm going to share my screen to that. Yeah, so this is the AsyncAPI Studio, right? So I'm just going to get rid of it. So if you are joining using the studio for the first time, you will definitely see like a general one of the pre-made or already made specific AsyncAPI document available, but we're not going to be using any of that. We are going to start writing our own AsyncAPI document for our server, right? And in order to do that, one thing I love about Studio is the ability to, validate our AsyncAPI document as we write it to see if we are actually writing the correct AsyncAPI document. And also we get this whole really awesome preview on the right hand where we're going to see the whole readable or human readable version of our document. So without no further ado, start by writing our document, which is going to be fun. So we're going to be writing our document based on the design I showed earlier. So in order to, when writing your AsyncAPI, the first thing you want to do is to specify the version of the AsyncAPI you're using, right? The AsyncAPI spec, right? So we have the version 2.6 and version 3. So the previous version was version 2.6, and now we are going to be using version 3, which was released last December. I mean, you can go to this YouTube channel and then check out this stream. You will see where I hosted one of the creators of the version 3 of the spec, where we did an overview of the version 3 of the AsyncAPI specification. Yeah, so we're going to be using the version 3. So the thing we want to do is say AsyncAPI 0.0. I mean, it's awesome because it also gives us this autocomplete of everything. So we have to define the version of AsyncAPI we are using. And the next thing we want to do now is provide information about our API, right? So we're going to say info. Um, we're going to say the info. So to make it more fun, right, I'm going to use a tool I built to better help me understand the AsyncAPI document structure called schema, which is already available on the AsyncAPI website itself. So I'm just going to open that up also now, so it doesn't look like I'm doing magic while writing the document. So let me quickly switch my screen to the AsyncAPI website. Cool. So what we want to do now is go to this. When you go to the AsyncAPI website, go under Docs. You see the Specification Explorer. So when you click on it, you can see we have the whole awesome user interface. So when I hover on this, you can see basically what I was saying, right? You can see it has different components to it, right? We have the Sync API, which says the AsyncAPI specification version of this document, which was what I mentioned earlier. So we have the ID, we have servers, we have info. So this info object is currently what I was doing about to write before I showed you all this awesome UI. So if I expand these, so what I have now, you can see I have this whole thing. So when I hover on the info node, right, you can see the whole properties of the info, right? So we're not going to be using all of these properties. We're just going to be using some of these properties, such as titles and version. So let's go back to our studio to continue writing our AsyncAPI documents. So I'm just going to replace my screen. Yeah, back. So I showed you earlier before, we have the title property, which is basically the title or the information, of course, because what this basically info object does is provide information about your API. And so we're going to say the title of our API title is going to be, let's say, collaborative drawing and charting application. So, or let's just say charting WebSocket API, just to make it more accurate. Sorry. Right, so we've provided title. We have to provide a version of our API, which is also important. And we're gonna say the version of our API is version 1, because of course it's the first version. And you can see all of the errors are gone, right? Because of course this is valid, right? But of course you're not done, right? So it's still not valid to our standard. I mean, you cannot provide this to your stakeholders or whoever is going to be interacting with your API and say, oh, this is my API. I mean, come on, it makes no sense, right? So what we're going to do now is we've provided the version of our API. We could go a little bit further by providing a description, our API description, right? Something to describe what this API does. I mean, the title might not be enough, right? So we can just say the description is, say, this API facilitates real-time communication for a collaborative drawing and charts application. Right, so this is like we provided the description of our API, right? And you can see, like, the moment I started like writing it, it's immediately also like updating here. So this is more readable to whoever is going to be consuming our API, right? So we've provided, let's leave this at this for now. So we've provided the AsyncAPI version, saying we're using the version 3, and then we provided the information about our API. And the next thing we want to do is provide the server, right? So if you go back to the AsyncAPI scheme visualization I just showed you earlier on, you can see in the specification, right? We have different components, like I mentioned earlier, right? We have info, we have operations, we have channels, and then we have servers, right? So if I expand this server node, right? You can see an object representing multiple servers, right? Because when you're building your API, of course, how do people connect to your API? I mean, it's really important, right? And that is what this server object or this server node, as you can see in the visualization, is for, right? So let's go back to Studio and then define our server. Cool. So let's go. Now we have to do our server. So you have to be careful because this is a YAML file. So it's really important how you structure it, or else you're gonna have an invalid AsyncAPI document. So we have to go back and then we're gonna say server. But then it's invalid, right? Because you can't say server because it should be plural servers, because you can have multiple servers. You can have development server, you can have production servers, you can have staging servers, you can have all kind of servers, and that's why AsyncAPI provides you with the ability to, define multiple servers, right? So instead of saying server, we're going to say servers. So to make this more formatable, let's give it some spacing. So instead of saying server, we're going to say servers, right? And then we have to, the next thing we have to do now is define like what kind of server is the first server we are using, right? But for now, we're going to use only the development server. We're not going to deploy this app probably because of time, but you're going to have access to the ready-made, like the whole source code that would be ready for deployment if you are willing to like give it a try. So we're going to define by saying development, because we are defined only for development, right? Because if we have a production ready server, so if you eventually maybe deploy this API and you want to connect it and also host your clients, so you definitely are going to need to provide a production server also. But for now, we're only going to use the development server, right? So once we provide the development server, the next thing we want to define is the protocol, right? As I mentioned earlier before, at the beginning of this stream, I mentioned how I'm going to be doing more of this live stream, covering so other communication protocols like Kafka and the rest. And so AsyncAPI is protocol agnostic, right? And that is the beautiful thing about AsyncAPI, right? So unlike OpenAPI, which I'm not gonna say, not a big, I mean, I'm a big fan of OpenAPI, but I think ever since AsyncAPI came out, come on. I mean, be honest, why would you want to use OpenAPI when, I mean, just kidding, you still want to use OpenAPI. So because AsyncAPI is protocol agnostic, unlike OpenAPI that only works with HTTP, so AsyncAPI gives you the ability to use multiple protocols, right? You can use Kafka, you can use WebSocket, you can even use HTTP. Yes, I'm correct. So I mean, it's just like all in one. It just works, right? So what we're going to do now is we have to define the protocol we are using, right? It's very important. I mean, you just have to like do it. I mean, you can't omit that. You can't leave that out. So the next thing we want to do is define our protocol, right? And then we're going to say our protocol is WebSocket, right? And to specify in your AsyncAPI document using WebSocket, you have to just use WS. I mean, if you have used WebSocket before, you already know this is like the how do we call it, like the abbreviation for WebSocket, right? So WebSocket. So the next thing we want to do is say host, right? And the host basically means the endpoint to connect with your server, or the endpoint connect with your API, right? So for development, we're going to be using localhost, right? So we're just going to say localhost, let's say 8787. So this is what we're going to be using. And you see now Studio is back, right? It's saying, oh, this looks correct, right? And you can see I have all of these, nice and really straightforward user interface showing here on Studio. So cool. Thing we want to do now is also like, we need to put a description for our server to, tell people what the server actually does. And then we're going to say description. say development WebSocket server running locally, right? Cool. So we've added a description to our WebSocket server. So the next thing we want to do is leave it like that, right? Because we're only working with development. So we're not doing any production, thing. So the next thing we want to do is define our server. So which is now we've got into the interesting part, right? I mean, trust me, it's worth it when you write a AsyncAPI document first. So we have the server, and then next we want to do, of course, if we go back to the AsyncAPI visualization tool, real quick. Yeah, you can see I said it many times that we have other parts, right? So we have the server with which we have defined, and then right, which basically says an object containing all the channel of the definition the application must use during runtime, right? So which means we have to define the channel, right? Cool. So what we want to do now is define our channel. So I mean, if you have used WebSocket before, I believe you already maybe are familiar with the term channel, which also can be known as like routes, topics, basically that's what channel does, like where you want to send a specific message in your API, right? So let's go back to Studio. And then we are gonna define the channel. I'm sorry if you are, hearing like a background noise. There's actually a construction going on behind my place. So please do bear with me. Cool. So we've gone back to Studio, and the next thing we want to do is define the channels, right? So we're gonna say channels, plural, not singular, channel, right? So we want to define our first channel, right? So our first channel in this our API, we're only gonna be working with one channel, right? Because we are building a collaborative drawing app. We are not sending private message. We are doing everything in public. So we are it's more like a group, right? So when you connect to the AsyncAPI channel, to the server, you have like you will have the opportunity to like communicate with everyone that is on that particular channel, right? So what we want to do now is specify the routes. Our channel name, of course, our first channel is going to be called routes, right? Which is the main channel, or you can call it anything you want, but for the sake of this document, we are going to call it root, right? Which is the main channel, right? So if you're using this AsyncAPI specification version 3, you would be familiar with all of these. So if you want to learn more, you can go to the AsyncAPI docs to learn more about the V3 and the required properties. And you can also check out the visualization tool I showed you earlier in the AsyncAPI website to better understand how all of these pieces are connected together to provide a single API document, right? So when we define the channel, the first thing we want to do is provide our channel address, right? So our address is going to be, just this main part, this single part, because that's what we are using, right? Now, the initial part for connecting it to our WebSocket server. So we're not creating multiple channels. We're just going to be using this one for now. So the next thing we want to do is provide the title, our channel title. I mean, to make it more readable, to make whoever is consuming or we communicating with our API understand how it works, right? So we're gonna say the title of our channel. We're gonna call it like main communication channel. The main communication channel. So that is the title of our channel. That we can then add a description. So once again, if you don't understand how like all of these things, like how I'm defining them, just go to the AsyncAPI document, learn more about it. It's pretty easy. Or if you're someone like me that loves to see things visually, again, you can use the AsyncAPI visualization tool. So let's just provide the description for our channel. We're gonna say this is the main channel for both drawing and chatting, right? Drawing and chat messages, because like I said earlier, we will have the opportunity to draw and then exchange messages, chat messages with each other, right? So we have defined the channels. This is our channel, right? But then the next thing we have to do is then define the kind of messages we can send or this channel can receive, right? Which is pretty important, because if we go back to our drawing on the whole architecture of our application, right? So if I to the whole drawing of the architecture of our application, you can see I specified that this is the kind of messages we are expecting. These messages, right? We can either send drawing messages or a chat message, nothing else, right? The client should only be enabled to send this kind of messages. So what we want to do now is go back to our VS Code, our studio. I can't wait to code, right? So go back to our studio and then go and define our messages. So the next thing we want to define now is messages, right? The kind of messages we can send to this channel. So we're going to say messages, but we haven't defined any messages, right? Because if you go back to the AsyncAPI visualization to visualize how our document should be structured. So if we close this one and then go to channels, right? You see, we have channel, right? So this is the channel. We've provided a channel title. We've provided channel address. We've had a description to the channel. So you can see then we have messages, right? So which is basically the messages. According to the document, it said a map of the messages that will be sent to this channel, like I mentioned earlier. So this is the kind of messages that will be sent to this channel, right? Okay. I think I've been talking too much. I have some folks on YouTube watching with me. Hey Tuli, hi, how's it going? Thanks for joining. We have Hagun. Hello, I hope you are enjoying this session. It's gonna be fun, trust me. Just stick with me. We're gonna be doing some really amazing stuff. Bella Packer, hi, how you doing? Thanks for joining. Bella from Twitch. Wow, awesome. So yeah, let's just continue. So we have the title defined, like you can see, we have the description provided. So the thing now is the messages. So I mentioned earlier, like the messages document is the kind of messages our channel will be able to receive, right? So in the document it says every message sent to this channel must be valid against one and only of the message object defined in this app. I know that's like a lot of English, right? So I'm going to break it down while we define our messages, right? So one thing I wanted to show you all is this components, right? So instead of defining in our server, in our channel, so instead of defining our message, like writing everything directly in our channel and everything, making all our AsyncAPI documents cumbersome, so AsyncAPI provides this really amazing aspect called components. And if we see in our visualization, let's just close this channel, we have these components, right? And components, this it here, there's a really good description. It says components are objects or an object to hold a set of reusable objects for different aspects of the AsyncAPI specification, right? So component means you can easily define reusable aspects, right? So messages we're gonna be reusing our messages. So why do we want to add code to them like directly in our channels, right? But when we could basically just define it in our like in a component structure, right? So let's go back to studio and just basically do that. So when we go back to studio, so let's just leave out this messages aspect for now. Oh, sorry, I forgot to switch back to studio. Cool. Back to studio. So let's leave out this messages aspect for now, right? Because I mean, and let's follow like the way we organization. So we have to define something called components. Components. So components, right? So I mean, components like you've seen in the visualization is used to define set of reusable objects. So it can also be used to define messages, can be used to define schemas, can be used to define a whole awesome list of things provided by AsyncAPI, right? So for now, we're just going to focus on the message aspect. Then we're going to say messages, right? Now we have messages defined. So what we want to do now is what kind of message are we going to put here, right? I showed you earlier in the drawings that we are going to have two types of messages, right? We are going to have we're going to have charts, right? So the first message we're going to define going to be called chart. Ooh. The first message we're going to be defining is going to be called chart, right? So what we're going to do is make this chart really, really adaptable, right? So this chart will be able to, we can, so, okay, just to make it more clear what I'm about to say, if you go back to our architecture drawing, no, not this one. If you go back to the Scali draw, cool. So if we go back to our architecture drawing, right? So you can see how I wrapped all of these in a box, right? So this box is called charts, right? So chart, why I'm naming it chart is so you can better understand it. So it basically means the client is trying to communicate to the rest of the clients, right? So it could be in form of drawing or it could be in form of texting, right? So what we're gonna do is create a single message that takes either one of these, right? And you can see in this whole saying as drawing or chatting, or I mean chat, which basically means like texting. So let me rephrase it to text of chat. So we say we can receive either drawing or texting, right? So we are gonna say go back to our studio and then create a message type or a message component that takes one of these two, right? Where we define these two. So we say we're gonna define the drawing, I'm gonna define the text. So let's go back to studio. Awesome. So we are back to studio, right? So what we want to do now is to define the kind of messages this chat is going to take, right? And I've shared earlier, it could take type of drawing, it could take type of text, right? So how we just have to do is that. So in the charts, we have to know, like I always like did in the earlier, the title and the description. So we're going to provide a title to make it more readable. And we're going to say, let's see, charts. I'm gonna say chat or drawing message. I don't know. Let's just call it chat or chat. Let's just say text or drawing message, right? So which is basically mentioned earlier. So we can use this component to either send a message type of drawing or a message type of text. So we're gonna provide the title, text or drawing message, and so what we're gonna do. Oh, so not title. Let's just the name. Yeah, that was a mistake. I mean, so let's use name instead of title. So that's the name of the component of the message component for chat. So what we want to do now is let's provide a description, like I always said, to make it more understandable for whoever is going to be consuming your API. So once the description, we're going to say this message handles both chat, text and drawing payload, right? So that is basically what this message is going to be handling. So now we've created the first message but we haven't actually defined the payload, right? Well, what kind of data is this going to be handling? So that's what we have to do, right? So if you go back, I'm going to be going back and forth. I mean, I'm switching um, from the visualization studio for better understanding of what we are doing. So we have the chart. So now we want to define the payload, right? So if we go back to our if we go back to our visualization, right? So, and we go to messages under components and the message object, right? You can see. So this is the message object. It takes these following properties, right? It takes the name of the message, the title. I mean, that was what I used instead of name the other time, but I replaced it. And then we have the description. I provided the description earlier, and then it has something called payload, right? Which is an object representing either a schema or a multi-format schema based on the existence of the schema property. And since if the property schema is present, use schema or use the default AsyncAPI schema otherwise. So you can use the this property basically uses JSON schema, right? So that what basically does. So you just have to provide a valid JSON schema. So if we expand it, so we have the name and we see the payload, so it's active. So now what we have to do now is define the payload. Like I've said earlier, the payload has to be the kind of object or the kind of message we are expecting this message component to handle. So if we go back to Studio, awesome. So if we go back to Studio, now what we have to do is define payload, right? And like I said earlier, the payload is the type of message we are going to be handling. So let's just say payload. So the payload type, if we go back again to our architecture, is an object, right? So you can see how I mean, this is just a draft, not the actual actual object content, but you can see it actually represented in an object, right? So which means the kind of data we are going to be sending to our chat message component has to be an object. So when we go back to the AsyncAPI Studio, and then so we have to specify type of object. And don't forget, like I said earlier, right? This is basically just JSON schema. So whatever it is you're providing here is JSON schema, right? It doesn't have to be AsyncAPI specific schema. It's basically takes a valid JSON schema. So if you're familiar with JSON schema, so you shouldn't have problem, understanding this part. So payload type of object, right? So then we can just continue defining our message payload. And what we want to do now, we've defined the type objects. So the next thing we want to define now is the properties, right? So what this message actually entails, right? So the data we are receiving, what does it entail, right? Which is the properties. So we're gonna say properties. So we're gonna say the properties, right? So what we're gonna say is, okay, before we define the properties, so let's understand the kind of data we want to send, right? So let's go back to this our architecture and see what kind of data we want to send, right? So I'm just gonna copy this whole data and bring it down here, right? So the one for the drawing first, because that is like the whole important thing about let me say the most awesome feature of what we are building, which is a drawing application, which means we have to be able to draw. So let's define the drawing first. So we have this. So now let's define the object. What we want the object to look like, the data we are going to be sending, right? So let's say we want to send the type. So when you are sending, you want to define the type of the message, right? So, or the type of the payload, because if you remember vividly, I mentioned that we can either send a text or a drawing. So we're going to say, then we need a type, which is going to define like the type of payload. So it could either be text or drawing, right? It could either be text or drawing. And then we also, so if it is drawing, like I said, we're going to be using drawing. So if it is drawing, we are going to need, extra properties, because so if I'm drawing, if I'm drawing here, right, you can see the way I'm drawing. So if I'm drawing and I want the other connected clients to see what I'm drawing, I have to somehow, track the positions of this drawing to better represent the actual position on my screen to the connected clients, to the rest of the folks that are going to be seeing what you are doing, or to the rest of the folks that are collaboratively joining with you. So we have to send the positions, right? So let's just say we're going to send the first position. We're going to say position X. We're going to X, which could be, let's say, a number. Let's just say a random number. So we're going to just choose like the position of the cursor or the position of the drawing on your screen. Position X, and then we're going to say position Y, because of course it's going to be in X and Y position. So what's the position Y? Also, we're going to define, let's just put a random like number. And then maybe right, do we actually need a timestamp? We could just say we can add timestamp, but I don't think that is necessary for the drawing. So what we want to also indicate that is important is actually the color, because if you remember, I said earlier, right, we want to, when we are authorizing the users, each user is like selecting their own colors. So when I'm drawing, right, so let's say when I'm drawing on my Canva, so let's just say this is my Canva, right? So when I'm drawing on my Canva, right, I'm saying black, right? But I don't want the other connected clients to see black, right? I mean, it doesn't make sense if everyone is saying the same color. Then you don't actually know who is drawing what, right? So, and that is why it is important to specify the pen color, right? So if I'm drawing, I'm gonna be seeing black for my drawing, but I don't want other connected clients to see black also for my drawing, right? I want them to see a specific color that is assigned to me. So that's what I'm gonna do, right? I'm gonna get rid of this drawing. So I'm gonna say, okay, so when we are sending the drawing payload, we want to also include the color, right? Then we're gonna say color. We're gonna say maybe this is blue, right? So this is like the basic. This is what our drawing payload should look like, right? It should take the type, which is gonna say either type of drawing. So of course, this could be the drawing, but for this, it's going to be drawing. So let's remove text. So type of drawing, the position X, the position Y, and the color blue, right? So now let's go back to, now that we've understood how our drawing payload should be structured, right? So let's go back there to go Studio to implement what we've just like written here. So going back to Studio. Awesome. So we are back on Studio. So now we have to define the properties using the structure of what we defined earlier. So we just have to replicate it. So the first thing we are, and like I showed you earlier, is a type, and the type of payload. So we're gonna say type, right? So we're gonna say type, but then we have to tell AsyncAPI what kind of type it should be. Is it a type of number? Is it a type of string? Is it that what type, right? And like you've seen in the example I showed you, it's actually a type of string, right? So we can either define drawing or text. So it has to be, we have to choose one. So what we have to do now is say type of string. So we've specified in our documents now that when we are sending, well, when we are receiving data or messages for our from clients, right? So we are expecting two type of data, right? We are either two type of payloads, right? We are expecting either you're sending a text or a drawing payload, and now that's what we are doing. So what we're not doing now, if we said type, we specify the type of string. So the next thing we want to do now is this one, right? I'm a big fan of this. So when you're writing your AsyncAPI document, always put description, right? Description makes it easy for whoever's going to be interacting with your API to understand what they are expected to do, right? So we're going to say the description of this. And you will see how it is important. I had description to this particular payload. I'm going to say description, and I'm going to say specifies this particular part, specify the type of message. You see, specify the type of message I'm sending. So I can say, e.g., example is going to be example drawing, right? Because if you see how I showed you earlier in the whole example I was making in the diagram, it shows like we can either text or drawing, right? And now I have to also description that when you're sending this message, you can either provide type, a type of drawing text, right? So is this type that we're going to use to validate incoming messages. So we're saying the type string description, we provide a description. So we've done the type, and if we come here, it's interesting. I mean, we are seeing everything in real time. Panel, if you scroll down, you can see in the message section, we have our first message with the message name of charts, of course. And we see the description. It says this message handles both text and drawing payload, right? And when we click on the payload, we see our first defined payload, which is a type. And it says, oh, this type is a type of string, right? So if you are going to define the type, you need to make sure the type you're passing is a string, right? So, and then you can see the description I had it, right? We're not done. So the next thing we want to do now, based on the example I did previously in the payload structure, is the position, right? So because we are defining, let's say we're defining the drawing part, right? So which means the next key is going to be the position X. Like I said, we need to be able to track the drawings from each users, right? So that we can then broadcast it and to provide accurate positioning in the rest of the connected clients. So we're going to say the position X, like I showed you earlier. Then we need to provide the type. Now this time, it's not a type of string, because if you go back, if we go back to our drawing, you can see position X is you see, it's not a string, right? So we cannot say type of string. We're going to use type of number, integer. So we're going to use type of number. So let's replace. So we are going back to Studio, and we are going to. So if you are just joining this stream and you are, getting this weird background noise, so like I said earlier, I didn't know this was going to happen when I scheduled the stream for today. So this is beyond my control. Please just bear with me with the whole background noise. So now what do is provide a position X, right? So we said we'll define position X. We want to define the type, right? So now we're going to say type of number, right? So we're expecting if you're sending us the drawing payload and you're passing the position X, it should be a number, right? So we're going to say a number, and then we're going to say add the description like I always did. We're going to say the description. I'm going to say the X coordinates of the drawing action, right? So we know what X does, right? So the X coordinates because I don't know if you're familiar with the web Canva, so you'll know how it's important, because when we draw, you're basically getting both the X and the Y coordinates. So we need to pass that to represent better, to get accuracy when we are sending these drawings to the rest of the connected clients. So position X, and so we need to pass position Y. The same thing, basically the same thing, number, and then pass the description, like I always said, description. So let's just copy this one, right? Awesome. So we have X, so we just have to replace this one with Y. So if we go back to our first message that we've defined, and you can see we have all of these already like readable, right? So we have this type, we have position X of number, we have position Y of number, and then we've defined our first message payload, right? So this is for the drawing, right? But then now we have to define for the chart, right? So to define for the chart, basically, what does that mean, right? So that means we have to somehow, I don't know, it's crazy. So we have to somehow define this payload for chat also. And then, so does that mean we have to, create a new message called, because ideally, what we could have done is saying drawing chat, call this on drawing chat, right? And then copy this whole, and then create a new one called text charts, right? And then we have to then define the one for the text. But then it then makes our AsyncAPI documents really, really unreadable. I mean, even though whoever is going to be connecting to your WebSocket server doesn't need to like know about this whole document, and then you can just provide them with these preview one rest. I mean, what about when you're going to be managing your API, right? I mean, you don't want this thing to look really unreadable, right? So what we're going to do, right, is take advantage of the schema components. So what does the schema component means, right? So let's just go back to the visualization like I've done earlier before. Okay, before we do that, we have a couple of folks joining us on oh my god, I mean, I'm not alone. Wow. So hi Mintu, hi, interesting stream. Yes, hi, thanks for joining. How you doing? I hope you stay till the end of the stream. It's gonna be fun. We have Mohammed. Hello everybody. Hi. We have Savage. Yo, what's up, man? How's it going? Hope you're doing good. Hope you're having fun. And I think we have a couple of Indian folks on the stream. I hope you all had a wonderful Diwali. I mean, I love Diwali, and I've always hoped to like experience once, have the experience once. And I hope maybe next year, maybe I'm gonna be visiting India next year, Bangalore, if AsyncAPI is going to host one of the conference there, and maybe I would stay till Diwali. I don't know. Thanks for having me here, and you're joining the stream and having fun. If you have any question, please keep it coming. And if you are just here to not make me feel alone, thank you. That's kind, all right? Thank you. Okay, so let's get back right to it. So the schema component I was talking about. So let's see what it's like. What it is like. What is the schema component, right? So if we go back to the AsyncAPI visualization, right? Cool. So let's look for the schema components, right? So we've seen in the component earlier, I showed you earlier. So we have messages, we have parameters, we have all of these things, interesting things. But what about the schema? Here it is, right? Then we have the schema. And it says schemas is an object to hold reusable schema objects, right? And that is basically what we are trying to do, right? We want to have these types of message payload defined, but then we don't want to put everything inside our message objects. That doesn't make sense. I mean, it works, but it makes our whole message object looks really tedious, right? And then we just have to take advantage of the schema objects, right? So the schema objects we're just basically going to take all our payload, put them in a schema, and then reference them from our messages. And that way our messages is gonna look clean and understandable. So let's just do that, right? To our studio. Awesome. So what are we gonna do now, right? We don't want to stress ourselves. And then let's put this back to charts. So we have message components. Now we have to define the schemas component, right? So what we have to do now is, define schemas, right? We're going to say schemas. So we're going to say schemas, right? So we'll define schemas. So what do we have to do? So like I said, if you haven't been joining, so the whole summary of what I'm trying to do, if you just join, is basically I'm trying to define types of message payload we are expecting to send to our WebSocket server. So our WebSocket server can then broadcast this message to other connected clients, right? So when clients our WebSocket server is expecting two type of message payload, right? So you can either send a join message payload or you can send a text message payload, right? So what we're now trying to do now is define this payload, right? And instead of having everything written under our chat message payload here, I mean, currently we have the drawing defined, but then we want text, right? But we don't want to like keep, defining everything under the same kind of payload and make it stressful for us. So we're just going to leverage the schema component, right? So what we're going to do now is, wait for it. What we're going to do now is get rid of all of this. I know, right? You're like, hey, so what are you doing? What are you doing, man? I'm like, chill. So what I'm basically doing is we're going to leverage the schemas components, right? So by taking the schema components, we're going to move our payload here. This stuff I just removed. We're going to move it into the schemas, right? So what we have to do now is then define our first schema, because I moved the drawing payload properties, and then I want to move it into the schemas property. The schemas component, right? So the first thing I have to do is define my first schema, right? And that's drawing, because that's what I'm trying to move. And I'm gonna say drawing, right? Which is the drawing payload. I'm gonna say drawing. So I'm gonna say the type. I'm gonna give the title, the name, title. Let's just say drawing action or drawing message or action or anyone. I mean, whatever works. So drawing message or action. So the next thing we want to do is define the type, right? And the type is an object based on what we just moved. Type of objects. So what we're going to do now, should we provide description? Yeah, they just provide, let's just keep the consistency, right? So let's just provide a description. Then we're going to say schema representing a drawing message, right? So the next thing we want to do now is paste the property we just copied from here, paste it here. Oops, a lot of red. So what we just have to like format this. Oops, sorry. I don't know if there is, I think it would be cool if Studio has some sort of like auto formatting for YAML files. I don't know if it works. If you are contributing to Studio, feel free to let me know if maybe I'm missing something. It would be cool, right? If I can like auto format this thing. So we have it high. I'm gonna format it very well. I don't know. It's not just me. YAML is stressful. I don't know. You just have to like get all this indentation like right. So awesome. So we have our first schema defined, right? So and then you're gonna be like, so Ace, now move the drawing payload into a schema component. Doesn't that mean the message component for the chat doesn't have access to this anymore, right? That's correct. It doesn't have access anymore. So in order for us, and if you come to these messages, you can see like no payload. There's no payload there, all right? But then we have this new segment that has all the payload we need, the data we need for this to work, right? In order to do that, we are gonna take advantage of the ref property, right? So what the ref property basically helps you do is basically helps you point to whatever component that you're trying to reuse, or so it works basically for any component, right? So we're gonna come to this payload, and before we had these whole properties and stuff, but we already moved it here into this drawing schema component, right? Or schema property. So what we have to do now is just reference it, right? And to our chat message access to this drawing, right? So we just have to use the ref keyword. So we're just gonna say ref, right? And then we're gonna say components / schemas / drawings. Oh, drawing, singular. Kaboom. You see, I mean, now our chat message component looks clean. It looks clean, right? And basically, when we come to this, you can see our payload is back, right? So basically, what is happening is we are just referencing this schema payload here. We're just referencing it here, right? You're saying, oh, we want to use this one, right, for our message payload, and that's why you see the same thing. You see, awesome. So what we want to do now that we referenced it is now our chat message only has access to the drawing property, right? But then we, like I mentioned a couple of times, we want to have access to two type of messages, right? We want to have want to be able to send drawing messages and also text messages, right? So which means our chat messages, our chats should have access to both drawing and text, but we haven't defined the text property, the text schema yet, right? So let's just do that, right? We go back to the schemas. We come to define a new one. We're gonna call it text, right? I'm gonna give it a title of, let's say, text message or action. Basically the same thing we're doing here. So sorry, we have to format it. Oops. So awesome. So we're gonna have to define the next one, which is the text. So we had the two. The next thing we have to do is define the type. It's gonna be an object, right? Because I mentioned it earlier, an object. So the next thing we want to do is go back to Excalibur. We can find our architectural drawing. Awesome. So like this is how we define the one for the drawing. We have to do for the text also. So for the text payload, one is say type. So type would not be drawing, right? Type has to be text. But then we don't need. I mean, if you're sending a text, why are you sending a position of X and Y and color, right? We don't need all of these properties. So we're gonna get rid of these properties. So what we need is gonna be a new property called text, right? Which is gonna be, I mean, the text is sending text, which is gonna be a string, of course. It's gonna be a string. Let's just say hello. And then we're gonna need like the time the text was sent. So we need to include timestamp of let's say date time. So now you see the structure of our payloads, right? So we have the one for drawing and we have the one for text, right? So we've defined in our studio, we've defined the one for drawing. Now we need to define the one for text capacity, right? Or capability, not capacity, sorry. So let's go back to studio. And so, of course, you see earlier, like it's a type of object, and I've specified a type of object. And then what do you see we have to define next, right? We need to define the properties, which is what I just showed you earlier, which is the type, the text, the timestamp. Those are the properties required for the text message. Now we have to define properties. So this is just basic JSON schema, right? So properties, so type. I'm gonna say the type of string, and then like I said earlier, like in the drawing we also define type, right? And then the type is basically either a drawing or a text. So we have to do the same thing for the chat message. And then we're gonna say type of string, and then we're gonna say the next one is the text, and then our text messages has to be a type of string. So string. So the next one I want to define is a timestamp. Timestamp. And then real quick, I mean, we've been writing the document stuff. You're going to see the advantages. Is implementing our SAP. So we have to implement a timestamp, and then we're going to say a timestamp has a type of, I mean, if we say string, is it valid? No, why should timestamp be a type of string, right? It has to be a type of date time. So let's just change from string to date time. Uh-oh. Now it's failing. So why is it failing? Well, it has to be a type of string, not date time. So it has to be a type of string, but then if in a format of date time, right? So, you know, I said earlier, this is just basically JSON schema, right? So we need to write a valid JSON schema. So you just have to go back to the type of string, and then we specify the format, right? So we know the format is going to be, we're expecting a date time format. So we're going to say the format, provide the format property, and it's date time. And boom, we have our text payload, right? Schema defined, right? So we have the drawing, and we have the drawing schema, and we have the text schema. And if you come to the AsyncAPI, UI, we have the drawing schemas, we have the text schema, right? And you can see the date. You see, it's so awesome, right? It's basically showing, right? So if you are going to be communicating with my API, right, you see that it has, when you're trying to like send a text, you know, you're going to send the text has to be the type. We have to provide a type. Okay, now something interesting. I just missed something interesting, which is, what did you see the differences between this and this? I mean, if you can see the differences, I mean, let me know in the comment section. I mean, so let me wait for 5 seconds if someone's gonna like guess the differences. Like the difference between the schema. What do you notice? Let's see, someone's gonna say it. See the difference between the schema type and the drawing type. Okay, no one is commenting. So I'm just gonna say it real quick. So I know some of you all might like have the answers in your head and like don't want to. So the difference is actually the details. You see how well detailed the drawing schema is compared to the text schema. Exactly, and that is the power of having the description. Thank you, Muhammad. Awesome, the description. You see, that is the power of having the description to this AsyncAPI document. So whoever is going to be consuming your API would have basic and good understanding of how to communicate with all of these things, right? And you can see in the drawing we have a type of string, but then we have a description that says specifies the type of message. Example, drawing, right? See, and then we have the position X that says the X coordinate of the drawing. We have Y that says the Y coordinate of the drawing action. So we need to have the description also for the text. The text, let's go back and add the description, and then we're gonna say type description. I'm gonna say the description for our type is a just copy this one. No, this one. Right, so type of messages. So we're gonna say put the example of text, right? And then we get had the description also for the text description, and then we're gonna say the actual message you're sending. The actual message you're sending, right? And then the timestamp description. Then I'm gonna say the time when message was sent. Awesome. So when we go back to the, you see now, is it not more readable than earlier? Awesome. So I always like tell folks to always add the description. I know it might not mean anything, but I promise you it goes a long way in making your API much more readable for other people that are going to be consuming it. So we've added the timestamp. So we have our schema already for the text. And but then in the message we said we can either send drawing or text. But in the message payload, we only have for drawing, which means if you are going to be sending message, you can only our server or our API is only going to recognize the drawing message, right? So we need to also tell our message, our chat message, to also accept the text message, right? So in order to do that, we are going to take advantage of the one-off property. I mean, if you are familiar with JSON schema, then you know how JSON schema has all of these properties of one-off, all-off, any-off, which is basically similar to like, I mean, from how do I put this in layman terms? Let's say the ability to actually use um, one of either properties you're providing. So one of is saying you need to use one of these messages or one of these data. Any of these elements you need to use any of these data provided, right? So it's more like it's actually a type of an array, right? You're providing an array of properties, right? And you're saying, oh, if you have one of, you're basically saying you need the message or the payload has to use one of these defined properties, right? And if you're saying any of, you say any of them, you can choose any of them. And if you're saying all of, basically means it has to have all of these things, right? But in our schema, in our architecture, we only want to use, we only want, when sending message, we only want to send either of drawing or text, right? Which basically means we need to send one of those. So our API is expecting one of those. So we're going to use the one-off keyword, right? And not to use the one-off keyword, we need to go back to our chat message. So we need to come back here, right? And then get rid of this. So now we are only specifying the get rid of this. And then, of course, so when you come here, you know it's gone. So then we need to say one of, what is it doing? One of, and you know, if you are familiar with JSON schema, you need to use these what's it called, hyphen, to provide you specifying an array. So we're gonna say one of, and then we're gonna say, to make it more better, I'm just gonna copy this instead of deleting it, and then we're gonna say one of, and then paste it right. So we're saying one of this ref. Well, I mean, of course, we're basically saying our chat messages should be able to use one of these specified schemas, right? So we've defined our first one, which is the drawing, and then we need to specify the second one. So let's just paste it again. And then we are going to text, right? We've updated our chat message component to take one of drawing or text, right? So which basically means our chat message can either have the drawing text, the drawing message, or the text message, right? So now if we go back to the payload of our chat message, then see. Now instead of returning just the drawing schema, now returning the two schema. So it's saying the payload adheres to drawing message action or text message action, which is brilliant, right? So that basically means we can send our chat message, can use either a drawing message or a text message, right? So if I expand this one, you see that's for the drawing. If I expand, then you get the one for the text, which is awesome. So you see, cool. So what we want to do now is we've already defined our message. It's brilliant. So the next thing we want to do, which is important, and is this. If you see in our message payload, we have something that says additional properties are allowed. What does that mean? So what this basically means is side of the message we've specified. Awesome, awesome, Hamed. Thanks for the question. Can the string be an enum? Like the type can be only on or off. Awesome. That is a really nice observation, and we're gonna get right into that, Mohammed. We're gonna see how we're gonna use that. Thanks for that. So, but before we go into the enum, we have to disable this, right? Because why we have to disable this is outside of the defined properties we've defined, which is the drawing and the text, right? It's basically saying additional properties are allowed, which means when the clients or whoever is going to be interacting with our API can send these, but then they can also add an additional property. But we don't want that, right? We only want these ones. We only want these ones, right? So we need to disable additional properties, right? So in order to disable additional properties, we just have to say after the properties section, we just have to say, oh no, my keyboard just died. I'm gonna plug in real quick. Awesome. Okay, and we're back. So we're gonna say additional property. False. Right? So that's just it. So if we go back to the drawing, you can see now it says additional properties not allowed. So which means you can only pass this type of data, the data payload. Like you cannot add any additional property. You cannot say name. You cannot, passing anything apart from the ones we've defined here, right? So we have to do the same thing for the text. We don't want additional properties. We just want the properties we have defined in our AsyncAPI document. So we just have to copy this and then enable it for this. Awesome. So now we have additional properties not allowed. If we go to our message payload, we can see additional properties not allowed. Additional properties not allowed. But then in our messages, additional properties are allowed. So we need to still enable it in our message payload, not just in the schema. So we need to also come to these charts and say, oops, what am I doing? Now our document is becoming big, so I'm getting lost easily. So now we have to come to these and say additional property. False. So if we come out of our message, it's still saying additional properties allowed. Am I using it in the wrong place? No. Okay, it's not supposed to be allowed. I don't know why it's still saying additional properties are allowed. Now we can start our first, folks. Okay, so just keep going. We don't want to spend time to figure out why that is not working. I mean, important ones are these ones here, which is the schema, the type of data we are passing. We've enabled, we've disabled additional properties, so we can only pass the ones we've defined. So Mohammed suggested, so the property is I'm actually part of our schema, right? Especially from our message payload, right? Because if we go back to our architecture drawing, awesome. So if you go back to our architecture drawing, you can see we said, right, we can every message we are receiving has a type, right? So a type of drawing or a type of text, right? But then what happens if someone provided anything else, right? Maybe a type of name. I mean, it would be valid, right? Because we are saying in our document, if you go to Studio, go back to Studio. Sorry. So if you go back to Studio, and if we see in our schemas, right, we are saying type of string, right? Type of string. So which basically means when we pass the type, we can pass any type, right? In as much as the type is string. So what we do now is we don't want people to pass just any kind of string, right? We want to be specific. We want it to either pass drawing, right? Drawing or chart, nothing else. Just drawing or chart. So in order to make that works, we have to use the enum property in our, so right, so in the type we have to include one more thing that says enum. I might say drawing. Awesome. So now we just provided in our type, right? So which means when you are sending the type of our drawing objects, right? You can, if you go to the payload, or let's just use a schema, you can see in the type now, it's saying the allowed value for our drawing schema is drawing. You can only pass the drawing. You cannot pass any kind of string because it would not work. Then it's against our schema, right? So we can pass either 1 or 2 or whatever, just to make sure whatever data is coming is part of the required ones, right? And then in our enum, we're always saying we only require, if you're passing data type, if you're passing message type for the drawing, we only require the type to be drawing, right? And that's what we just did. And then let's also do the same thing for our chart. So let's just this type here. Oops. And then say chart or text. I just say text, right? So the same thing basically happens for text and the type. So it says in the type, we allowed the only value you can pass is text, right? And that's just it. You cannot pass any kind of value, just text. So so let's just leave it at this. But one more thing we are missing is actually required properties. So we have all of these interesting, awesome properties. We have text, we have text, we have timestamp, we have type, but they are not required, right? They are not required at the moment. So which means if I send, when I'm sending my message, so if I'm sending timestamp text and I did not specify the type, it would not work. I mean, it would work, but it wasn't supposed to work. It's supposed to fail, right? And the reason why it's going to work is because we did not specify the required properties, right? So if any of my connected clients is trying to send, let's say, a chat to the rest of the clients, right? And when sending the client, and when the client is sending, he's just sending the type and the timestamp, right? But the client is not sending any text. Is it supposed to work? Like our server is not supposed to like respond, but it's gonna work because we didn't specify the required properties. So, but what we have to do now is specify required properties. And to do that, we just have to come here and then say required, passing the list of required properties. And then we're gonna say the first one, type is required. The next one, we're gonna say text is required. And then we're gonna say timestamp. right? Timestamp is required. So if you go back to our schema for the text, you see now we have required. So which was sending, let's say a data or a message for text, and one of these things is missing, it's not gonna work, right? It's gonna say, oh, this is text is required. I mean, you cannot send a text without providing a text property, right? And then let's just do the same thing for our drawing schema. Let's say we're almost done. We're almost done with the whole schema specification, and then we're gonna say the text properties. I'm sorry, the drawing properties. We need to pass in required, and I'm gonna say required. I'm gonna say the first one, required. Position X is required. We're gonna say position Y. Position Y is required, right? Okay, one thing is missing. Did we make a mistake somewhere? Oh, a typo. So position X is required. Now we've added required properties, both text and drawing schemas, right? But I think we are still missing something in our drawing schema, because if we go back to the AsyncAPI, our architectural drawing, our WebSocket drawing, you can see in the in the drawing property, we have one more thing called color, which I mentioned a couple of times. We want to also specify color for whoever is drawing, because we don't want everyone to have to be seeing the same color on their canvas. So they have to have different colors to know who is drawing what, right? So we need to go back to our schema, our AsyncAPI document, right? And add color, right? So come to this, and then we had color property, and then we say type of string, of course. And then we're going to say description, just say drawing color or pen color. So pen color. So what we want to do again is add color as part of required properties. And we had done, right? I mean, we are not done. I mean, but we are done with defining the messages, right? So we have the message for drawing. So if you go back to our architectural drawing again, I know I've been switching screens a lot. And see, we had done with this whole part for defining the kind of message our WebSocket server, right? So we are done with that. So now what is still missing? So we only have two things missing, right? We have the client authorization, because we haven't done that. And then we have the message type of error. I mean, because if you already followed with this one, then you should know defining this one is easy. So just have to basically follow the same process as this. But then let's do the one for authorization. So to do that, we have to go back to AsyncAPI Studio. Awesome. So we have to go to AsyncAPI Studio, and we have to do one more thing, right? We need to do a new message. So we have the chat message component, which is done. We don't need to do anything there. So we need to do one more thing, right? Let's just create a new message. Let's call it auth, right? Which is going to handle the one for authenticating our users. So we're going to say the hot message. But what does this hot message contain, right? It basically contains name and color, which is the required properties, right? So now we don't have to do that in a schema. We can just directly do that in the method component, because that's only where we're going to be using it. We don't have to, and it's basically simple. So we don't have to stress ourselves. So let's just do hot. So let's just say the name. Let's give our name. Let's just say server, or let's just say API hot. And then let's say the description. So the description for our authorization is going to be, let's just say this message handles the WebSocket connection instance, right? And then you're gonna say the payload, of course, what we're expecting. The payload. This message, so the message we're defining now for the auth, I mean, instead of calling it auth, let's just say connection. So let's just call it connection, right? Because this message we are defining we're gonna send, of course. If you go back to the Excalibur drawing of our architecture, so when the client initialize a connection to the WebSocket server, right? So if the connection is successful, we need the server to then send the client back an acknowledgement saying, "Oh, connection established," right? So we need to define that the message the server is going to send to how do I do it? So let's just do like this. Right? So now within our WebSocket server, after the client has successfully authorized or successfully created a WebSocket connection or a WebSocket instance, we need to send some sort of acknowledgement to the client saying, "Oh, connection successful," right? And that is the message we are defining now in our AsyncAPI Studio, right? Acknowledgement. Let's just say connection right? So we're saying connection acknowledgement. So we're acknowledging the connection. So we're acknowledging the connection, right? So now we need to define the message, this particular, exactly like an handshake. Thank you, Mohammed. So we need to define the kind of message the client should be expecting, right? So that is what we are doing. So let's go back to our studio. Awesome. So that is what we are doing. Call it instead of saying connection, let's just call it acknowledgement, or let's just call it handshake, just like Mohammed suggested in the comment. So let's just say handshake, right? So connection establishment. Let's rename this acknowledgement. This is a connection acknowledgement. So I don't know. I think I have to spell acknowledgement. I'm just gonna go with it and say so now we've defined the description. So let's just define a payload. So what kind of payload are we expecting? So we just want to send back the numbers of connected clients and the status, right? So the status can be, so we're going to say 0 for failure, 1 for successfully connecting. So let's just define the payload, right? So we just have to say payload type of an object, right? And then YAML. So payload type of an object, and then let's just define the properties, right? The properties for our handshake. So we're gonna return just two data properties, which is the number of connections and status, right? So we're gonna say the first one is gonna be number of connections, which is the number of connected client, number connection. So we're gonna say it's gonna be a type of let's say number, because this one return the numbers of people connected. If you establish a connection, and then the next thing we want to do is the status, a type of number, right? So the same thing. So status can be 0 or 1. So we can just add description again, number of connected clients, the status type of number. So the status can be so we can say 0 or 1. So just like Hamid mentioned earlier about the enum. So we know if you are going to, like, if you're a client and you successfully made a connection to the AsyncAPI document, to our WebSocket API, you already know that you are going to get the number of connected clients, and then the status, right? So which basically means description. Let's add description to make it more So I'm gonna say how do we call it? What should we call it? Should we say zero? Zero means the I'm trying the status of the connection status, where zero zero means failed and one means successful, right? Cool. So now this is what you're expecting if you eventually successfully put to our WebSocket server. Awesome. So now define the required messages for our application to work. So we have two messages. We have the handshake and we have the chat, right? If you have any question, feel free to let me know. So now we have these messages and the schema defined. So what do we do next? What do we do next? So what we have is connect these messages available to our channel, because right now these messages are just in our AsyncAPI document, right? We don't have access to them yet in our channel. So in order to make it available in our channel, we are missing before we can even decide to connect it to our channel, which is the operation. Right. So what are we going to do? Like the operation, what is the client going to do? Because the client has to connect to a specific channel to communicate, or where how do we so the client has to eventually send this message to a specific place. Is how would the client receive a message? And so we haven't done none of that, and that is the only missing piece in our AsyncAPI document, and we just have to do that, right? So before we specify the operation, so let's just go back to visualize our AsyncAPI document to see. Let's go back to the AsyncAPI visualizer to see what the operation is all about, right? So let's just switch to the AsyncAPI visualizer, and then we see in the AsyncAPI document. Oops. So I don't know why. Okay, there's a bug in the schema. So let's just refresh it to. So now when we think about document, the initial node, you can see it has all our properties, but then it has this operations property, which we haven't done. I mean, we have done. We've created components, but we've created info, but we haven't done operations, right? And then you can see it says operation holds a dictionary with all the operations this application must implement. I mean, we haven't done that, and that is like the key part, right? And then if we expand the operation node, this is the operation node, right? The operation node has a lot of interesting properties, right? It has an action, it has a title, summary, description, the channel, and the messages, right? And what we're going to be using in this AsyncAPI and our API document is basically the action, the title, of course, the description, of course, the channel, and the messages. So that is basically what we're going to be doing, right? So now let's do that real quick. So let's go back to our AsyncAPI document and do that. AsyncAPI Studio. Awesome. So now let's define operations. Now we have two types of operation that we're going to be using here, right? We only have, no, not two, I think three, right? So we have to send chats, right? We have to send chats, we have to receive chats, and we also have to connect to WebSocket, right? So that's like three, right? So let's just define these three operations. So the first one is actually, connecting to WebSocket. So we're going to say connect. Let's say our first operation is to connect. So our first operation is to connect, and it has to receive an action. So if you go back to the visualizer again, we see in the operation, we have the action, and the action basically says a lot of values are sent and received, right? So you send when it's expected that application will send a message to the given channel, and receive when the application should expect receiving messages from the given channel. So for our purpose here in the connection, what are we doing? What do you think the action should be? Should it be send or receive? I mean, it should be received, right? Because we are expecting a client to send us a message, right? And the message is basically establishing connection, right? So if you go back to our diagram, our architecture diagram, you can see this part, right? When initially a client initialize a connection, right? You can see receive, exactly, Muhammad. So this is because the AsyncAPI document we're writing is for our server, right? And then for the connection, the client has to send a message to our socket, our API, right? Requesting to connect, which means our API or our WebSocket server in this instance is expecting a client to send a message requesting access to connect to our server or access to establish a connection. So which means our connect operation is expecting a receive action, right? Our server is waiting for a connection, right? So our server is waiting to receive a connection from whoever is trying to connect, right? And that is what we are going to do, is receive. So, but then what is this part? I haven't actually mentioned this particular part, right? And I'm going to do that. So just hold on. So now let's just define the receive. Go back to the studio. Say action. Of course, then we know the connection operation is receive. Receive. So we have the action receive defined. So we need to specify the channel. So we mean, of course, we are saying our server is expecting to receive a connection. But then where is the connection going? But we only have one channel, which is the root channel. So we just have to like say, okay, it's gonna happen in the receive channel, sorry, in the root channel. So we need to like specify the channel because I mentioned it earlier in the visualizer document, it's a KPI document, visualizer, that in the action we have the action and then we have the channel, right? And the channel basically say a simple object to allow referencing other components in the specification internally, and so we have to specify the channel. So if you go back to the AsyncAPI document, so we need to specify our channel, right? So let's just say channel. I mean, it says referencing, right? So we're basically going to reference this channel, and I mean that's the only channel that we are using. So let's just reference the channel, and I mean that's like where the connection is going to happen. So we define the channel, and then we just reference it, right? Ref. We're going to say slash channels slash root. Awesome. So what did you notice, right? We have a new thing appearing on our user interface, right? On our Studio UI. Now we have this operation component. Awesome, right? And then it says our first operation, which we had a description that said this is the main channel for both drawing and chat messages, right? And that this is available because we are referencing it here in our first operation, which is the connect, right? And you can see it has the operation ID connect. And then if you want to interact with our WebSocket API, right? You have to connect. In order to connect, you need to be looking at this particular part, right? So now we're not done, right? So we need to provide more details. So let's just provide the description. The description, we're just gonna say, let's just click triggers, socket connection, right? So just trying to like connect. So that's the description we're gonna use. And then the next thing we have to do now is to specify what kind of messages this operation is going to be expecting, right? Because we are trying to connect, right? But then the WebSocket server, our WebSocket server, right, it needs to expect a specific kind of message, right? It doesn't want you to like send any kind of message and then takes it in, right? But then, so I already visualized, I already showed you in the architecture we did here in the drawing this message. This is what we are saying, this one, because we haven't spoken about it, right? And we say when you're trying to initialize a connection, your connection should come with this authorization data. I mean, we're just using it for auth. I mean, if you're going to be doing authorization, you definitely don't want to do it like this. But then for the sake of this workshop, we're just going to be using this as a normal message payload. So we are going to say authorization. So when you initialize a connection, or when you're trying to initialize a connection to our WebSocket server, we expect you to send this data, right? Cool. So now let's go back to VS Code. I'm sorry, VS Code. I can't wait to actually write the server. So now let's go back to Studio. Awesome. So now what we want to do now is provide messages. Something cool is going to happen here, and you're going to see it. So now let's provide a message. So here we're going to use only because now I'm instead of saying message, I'm saying messages. Because if you go back to the visualizer basically says messages, not message, right? So if you go to the operations, if you go back to the message, it says a list of REST. So now listen very carefully. This part is actually really important. So it says the messages part of this channel says a list of reference pointers pointing to the supported message object that can be processed by this operation, right? Then look, it says it must contain a subset of the messages defined in the channel reference in this operation. This part is really important, right? So it's saying if we are trying, so now if we are trying to pass a message for our channel, for our operation, right? The message we are passing has to exist in one of the messages passed in the channel, right? Which basically means if we go back to our studio, right? If you go back to studio, basically means so if we are trying to pass a message, so if we say messages, so of course it's an array, so we need to like do it the appropriate way. So we're gonna say ref. And then let's say they just pass the message, right? Let's say $, hashtag, say messages, or let's say components slash handshake messages slash handshake. It didn't work, right? But it was supposed to work, right? Because we have this message here, right? In this list of our messages, but it's not working. But it can't work because that is not the rules. They're not following the rules, right? Because in the AsyncAPI document, it says it must contain, so whatever messages we are passing in the operation must contain a subset of the messages defined in the channel, right? But then if we go back to VS Code, I'm sorry, what do I code? Studio. If you go back to Studio, right? We don't have any message in our channel. It basically means we cannot pass this message. It's not valid. Even though this message exists in the components, right? In the message components, it would not work because if you are trying to pass a message for your operation in our instance, this connect operation, then this message has to exist in our channels. But in our channels, we haven't defined any message at all, right? So we need to do that. We need to pass the message. So what we have to do now in order for this to work now is we have to come to this channel and then say messages, right? Messages. Then we have to then name our message by saying handshake. Then we reference this one here. So we reference our message here, right? Handshake. Then we replace this one So instead of saying components slash messages slash handshake, so what we're going to be saying is channels slash messages slash handshake. Come on, that should work. Why is it not working? So let's see where we are we made a mistake. So we have messages defined, and then we have the handshake name. I hope it's not LinkedIn. So we have the connection, we have the description, and then we have the messages. Oh, do you see where we're having the problem? I already see where the problem is coming from. So the problem is coming from a mistake we made here because we're saying channels, messages slash handshake, but then it is actually channels. Roots was the channel name, like is actually roots, but channels is actually an array. Like we can pass many channels, right? But because we only have a single channel, I for some just say channel slash messages, but instead it should be channels, right? Because if you say in our operation, when we were specifying the channel, we said channels slash root, which is we are specifying to this first channel we have here, the first and only channel, of course. So we need to update these channels, channel slash roots slash messages slash handshake. Now it's not even working. What is happening? What is happening? Let's see. So we have the messages saying channels, routes, message, handshake. Cool. So why is it not working? Let's see. I mean, watching live, you can help us see why it's not working. It should be working. Duplicate key description. Duplicate key description. What do you mean? So let's see. Let's try to figure out why it's not working. So we have the description, define messages, and then we define our first message, which is the handshake, and then we define the components, messages, and then the handshake. And then the operation, our first operation, and then we define the action. We specify the channel, the description, and we say messages. $ref, channels, routes, messages, handshake. This should work. Say, is it because you have already linked a slash root there? You mean in this place? No, I mean, of course not, because this is actually a requirement based on the document earlier. Because we have to specify the channel, because if we did not specify this channel, then this is not even valid at all, right? So I see that's not a problem, Mohammed. Why now? Let's see. So define connect operation, the action. Oh, come on. It should work. What is happening? A list of it must contain a subset of the message defined in the channel reference expression. Yeah, I mean we already did that, right? Oh, come on. channels, routes, messages, right? Channels, routes. I mean, let's see why it's not working. Okay, I mean, our message is valid when we remove this one. Everything in this place is not allowed. Ref component must match component messages. Oh, is it connect? No. It's not to be working. Now we're stuck, right? Let's see. We have the messages, we have the handshake. Oh, should we change this to handshake? Let's see. This is not a problem. This is strange. Very, very strange. Summary, title, description, we have messages, and we have the message name, and the button the dollar sign left component, message slash handshake. Everything seems okay the moment we get rid of this, which is strange. Right? So we specify the operation name, connect, action, save, channels slash routes. But when we define messages, and then we are saying message name of handshake. And we're saying it has a dollar sign ref of hash component slash messages slash handshake. I mean, is this not what we were doing before? What? And then we come to this now and then say messages, and then we say dollar sign ref, and then we say hash channels slash routes slash handshake. Operation message does not belong to the specified channel. What? I'm trying. I'm trying to understand why saying handshake does not exist. Because we have channels, routes, handshake, right? Channels, routes, handshake. But it's saying it doesn't exist. Wait, it exists. Oh my god. We missed one thing by saying messages, bro. So I don't know. I mean, it's crazy. So that is what was missing. So what was missing was this message aspect, right? Because when we were trying to reference the messages here, we were basically just doing channels, root, message name. So, but instead, it's actually channels, roots, the messages, and then the message name. Exactly, Muhammad. Exactly. That was what we're missing. I mean, that's crazy. I'm so glad we were able to resolve that. That's so cool. So now that we have this operation like fixed, so let's add a description back. Say description. We're gonna say triggers or initializing this WebSocket server connection. Cool. Oh, awesome. So we fixed that eventually. Thanks to Mohammed. We have to fix. So the reason why we were having this issue was because we did not follow the appropriate paths to defining the messages in our channel. So now we have defined the first message. So basically, the interesting part of this is that when we are defining the messages from the operation, right? We cannot reference. It's a type of message. We can direct assets. It would work. So whatever define to specified channel that operation belongs to, right? So because we only have one channel, and we're saying our connect operation exists on our root channel. So whatever message we are gonna be sending, because of course we are receiving data, so we have to like respond. So the messages, whatever message we are passing now, it says messages, right? Because it means you can pass more than one message, right? So for our use case, we're only sending just one message. And so this handshake message, in order for us to make it work, we cannot reference it from the component. We have to reference it from off, right? And in order to make that work, we have to first define that message in the channel like this. And that's basically what we are doing. And that is the use of the AsyncAPI specification version 3. You have to do it like that. And what this basically just makes it easy for you to understand how to communicate with the API, right? Unlike the previous in version 2.6 and also like previous versions, you have to basically understand the whole concept between pub sub, because you don't know when are you publishing, who is publishing, am I publishing, is the server publishing. So this way now it's really easy to understand it. So that is that. So now we have this our first operation created, which is a connect operation, and now we can see it now. We have here. So our first operation, it says this initializes WebSocket server connection, accepts the following message, right? So this is the only message sending: number of connection and the state of the connection, right? Now we know we have you only. So if you are going to connect to my server, our server. So if you are the client or if you're the consumer, so if you're trying to consume our WebSocket API, you're trying to interact with it, you already know you are going to send to this place. So this channel means you're going to receive, not send, bro. So you are receiving, and that's how we have this receive. It means our WebSocket server is going to send to you. So you are the one that's going to receive this message, right? So this operation is only receive. So on the server, we are receiving, but on the client, you are sending, right? No, sorry, mistake. So on the server, like on our server API, we are sending. But if you're consuming the API, it means you're going to receive, right? So you're going to receive. So this is the message you are expecting: the number of connection and the connection status. Awesome. So now that we've done connection, so let's do for the rest, right? So let's do for sending and receiving messages. So we need to define the next one, which is basically send charts. Send charts, the same flow, typically send charts. But now for send charts, what should the action be, right? Is it send? Is it receive? I mean, it's send because you have to send. I mean, even from the name send chart, it means you are sending something. So we're going to say send. Basically, you have to send to this operation. So send, what are we sending, right? We're going to say first we have to provide a channel. We are still using the same channel. We're using the same channel, the route, because that's the only channel that exists. So everything we're doing, we are using just this single channel. And then what message are we sending, right? Same message. So the same flow. So just copy this one. And don't forget the rules, right? But we're not sending handshake. We are sending this message, chat, right? So we're sending chat. So we're sending a chat message, right? But then it would not work because we haven't created the message in the channel. So we have to do that. So we have to come to this channel under the messages, create a new one called chat. And then we're gonna say $ref. Just basically kind of copy this one, paste it, and then say chat because it has to work this chat component. Awesome. So we have it. So if you go back to the list of operations, we have another operation here. So we have connect. Now we have send chat, accept the following messages. And now you can see this one basically just works out of the box, right? Because when we reference the chat the chat components, and we know the chat component already comprises of two types of messages, the drawing and the text. So all of this is already like available since you can see we have it. So which means this, if you're gonna be sending text, you have to be sending either of these, right? Awesome. So if you have any questions, feel free to drop them in the comments. I'm on the lookout for them. So now the last operation we have to define is the receive chat, right? Because when we send chat, we have to receive chat also. So we need to receive the receive operation. So we're gonna say receive chat. Is basically, I mean, we're basically just copying this, right? We're just changing the name. So we're just basically copying the chats, paste it, and then change it to receive. But then we have to change the operation, right? Because the operation cannot be sent, it has to be received. We want to receive chat. So the action is receive, but it's failing. Why is it failing again? Did I spell receive correctly? Oh, typo. Awesome. So receive. Now we have three operations happening in now, right? We have the first one, the connect, which basically acknowledges. We have the send, which is basically going to when you're gonna send messages, and then receive where you're gonna. So we have the operations already defined, and I think we are done, right? I mean, I guess this is how it's a document. I mean, we spent the last let me see 2 hours defining our document. And I mean, that's cool. So we're done, but we're done. I mean, we haven't said anything about this. Let me switch real quick. Escali draw. We haven't really said anything about this, right? This is missing data, right? So when you initialize a connection, you follow, right? That we're going to use to connection, right? Do that with some API, which is API bind. Right? So we're going to use the daily. Let me show you real quick what bindings actually does. Bindings. Let me switch my screen quickly. What's a good binding? Okay, so just don't let me do that. Let me just explain what binding basically does. So what the binding basically does is Okay, escalator. So what bindings basically the AsyncAPI bindings does is it gives you the ability to provide protocol specific information, right? Because AsyncAPI is protocol agnostic, right? Which means we can use different protocols, Kafka, WebSockets, AMQP, and the rest. But then all these protocols have different informations that are needed, right? I mean, in Kafka, you need like Kafka topics, you have all these things, but in WebSocket, you have other things, right? So basically, what this bindings does is allows you to provide protocol specific information. So information that are specific to WebSocket, right? You can use bindings for that. Information that are specific to Kafka, you can use bindings for that, right? So that's what we're gonna use, right? So what we want to do right now is provide that says, okay, when you're establishing a connection, right, we want you to provide this information, this username and color, right? But then how you are establishing your connection, right? And because WebSocket kind of act like HTTP, I mean not HTTP, but kind of act like HTTP. So it supports adding headers, right? It supports adding query parameters, right? So we can then specify and pass these informations, so we can retrieve this information. So the client can pass this information through the um, query parameters, and then the server can then read this information from the query parameters, right? So we just have to then specify that in our AsyncAPI document. I mean, if it is Kafka, I mean, you don't want to do that because Kafka doesn't have support for query parameters. So you basically want to provide Kafka-related information. But because this is WebSockets, we have providing WebSocket-related information. And basically, that is what binding is all about, providing protocol, so specific protocol-based information. So now, how do we do this? How do we tell our now, how do we specify it in our AsyncAPI document to read or provide or read this document from the query parameters? So in order to do that, we just have to go back to Studio. So let's just switch back to Studio. Awesome. So now we are back in Studio. So in order to provide these specific information for our WebSocket server, so we just have to create something called bindings, right? So like I already explained what bindings does. So, but in WebSocket, right, provide so you can in the AsyncAPI you can provide bindings in different levels of your AsyncAPI document, right? You can provide bindings in server, in the server component. You can provide bindings in the channels components. You can create bindings in the message. So you can basically create bindings in different places in your AsyncAPI document. But for WebSocket, I think you cannot provide bindings in the server level. You can, but you can provide it in the channel level, right? And that's what we're going to do. We're going to provide our binding information in the channels level. And not to do that, we just have to come to this channel. Of course, we only have one channel, which we are using to handle everything and for the whole communication. So we need to come to this address. Sorry, not address. Come down here after we define our messages, then we can then extend it by saying bindings, right? Then we can say bindings. So the bindings we're providing now, so when you specify the bindings property, you need to then specify what's protocol. But like I said, like AsyncAPI is protocol agnostic. So if you're saying you want to define bindings, you also have to define like the bindings, like what binding protocol are you defining. So we are using WebSockets, so we have to say WebSockets. WebSockets, right? And now, like I said earlier, the WebSockets. So if you come, let me change real quick to the AsyncAPI binding repo where you can learn more about different bindings and how to implement them. So if you come back to replace our screen and come to WebSocket bindings, so we have this whole repo for bindings. So feel free to check it out. I'm gonna share the link. Awesome. So we have these binding repos where we have all how to specify all these supported protocols bindings in the AsyncAPI and at which different level you can define them. And you can see we have AMQP, different Google PubSub, HTTP, IBM MQ, MQTT, Pulsar, Solars, which is interesting because these live streams, I'm going to be doing them more often, right? Where I'm going to be experimenting and doing workshops about different protocols, this API. So now what we're going to do now is is go to the WebSocket we have for WebSocket, of course. So we just click on WebSocket. And then you see, this is the WebSocket bindings. And like I said earlier, WebSocket bindings doesn't support like server level bindings because it says this object must not contain this name. Its name is reserved for future use. So for now, you cannot specify anything on the server channel on the server level. But then on the channel level, it says when using web channel represent the connection, and that is where we are actually initializing our connection, right? So the channel represents the connection. Unlike other protocols that support multi-virtual channels like Kafka, that support like topics, and stuff like that, per connection, WebSocket doesn't support virtual channels. Or put it another way, there's only one channel, and its services are strongly related to the protocol used for the handshake. For example, HTTP. I already like mentioned this earlier. So we have the fixed fields, like the field supports. We have the method, we have the query, like I mentioned earlier, we have the headers, like I mentioned earlier, and the binary versions, right? But for our workshop today, we are going to be using the query parameters. I mean, if you're already familiar with HTTP, you know how you can pass query parameters by just saying, create these, and then say name, and then say Mohammed, right? And then when you say like then you retrieve it by saying the query.name, and then it returns Mohammed, right? So that's basically the same thing with WebSocket, right? So now let's go back to our our studio. We're almost done. We're gonna start coding. I mean, cool. Then let's go back to our WebSocket as a studio and do that. So now we've seen what is required. So we just have to say, so with my WebSocket, then what part, right? It's query, but it's in the query parameters. So we're gonna say query. So which means we want to like read from query, right? So you're saying if you want to initialize this connection, you need to pass this name or the username and color to your WebSocket connection initialization query, right? So we're gonna say query, and then we're gonna say type. Oh, sorry. Of course, type, we're expecting an object. Query parameters is an object, so type of object. And then we're going to say provided properties, right? And we're going to say properties. So if we go back to our architectural drawing, we are going to see, right? So username and password. Username and color. We don't need password now, so we just want the username and the color, and so that's the properties that is required, right? So we need to pass the property. So now let's go back to the studio. Awesome. So now when we're back in the studio, now we need to define it, right? So we need to say username. That's the properties required. Username, type of string, right? So let's say description. Client's username. So now the next one is color. We're gonna say color has a type of string also. And then we're gonna say description, pen client's pen color or drawing color, pen color. Let's say pen color. So now we have the query passed. Now, if we go back to the channel, now you see what happened, right? We didn't have this part before, but now we do. And now it's saying we have a channel specific information. So now if you are trying to establish a connection with our WebSocket server, now you need to know there is something you have to provide, which is this channel specific information. So when you click on it, you see it's a query, and when you expand it, it says it requires a query parameter of username and color, right? So that is a requirement. So you need to do it, right? So we need to also do one more thing to make sure these two are required. We've done it before. Just say required the username, and then the color. So we know these two are required, and that is the whole AsyncAPI document for our WebSocket collaborative drawing application. Oh, I mean, it's awesome, right? So now we are done. Like we are not writing any of our AsyncAPI. We're not writing AsyncAPI again. I mean, you are like, oh, Ace, we've been writing this like for, but we are done, right? Now we have everything written, and now this is so awesome, uh, because the reason why this is really awesome is this basically just provides a clear and concise texture for our WebSocket API. So if let's say Mohammed is going to be communicating with my API, and then Mohammed has to wait for me to build the API first before he can try it out. I mean, is that really going to work? But now imagine how both me and Mohammed are like together, writing out, designing how we want our API to work. And then I can just like give Mohammed this async API first, this async API spec, our async API document, and Mohammed can just basically, do some mocking with this document, right? And we have like amazing tool like Microx. So if you don't know, special out to Microx, I can just share a link to Microx real quick. Microx, which is an API mocking and testing tool, right? And which basically supports async API. So you can just use Microx to just pass in our async API spec, our async API documents to Microx and then mock it, right? Just communicate, interact with it without even writing a single line of server code. And then Mohammed can basically just understand how the whole API works, right? I mean, isn't that cool? And then you can also use some of these API tools like AsyncAPI generator that to generate any code in any language, right? So you can basically just take this spec, this AsyncAPI document, and then generate code based on it. I mean, mind blowing, right? I mean, so it's not time wasted, because if you compare these, if we have started writing our server, we would have taken longer than this, because then we have to be sure of the kind of message we are defining. We have to have this going back and forth. I mean, it's all stressful. But when we do this API spec first approach, it's so awesome. Like you basically fall in love with it, right? So now we've defined our AsyncAPI document. So we can use the AsyncAPI generator to generate our server code, but we're not going to do that, right? I mean, that would ruin the fun of it, because that's like basically going to be done. But I don't want us to be done yet. I want us to write our server ourselves based on these AsyncAPI documents. So let's get right into it. Now we have our AsyncAPI documents. Now we just have to start writing our server. So for our server, we're going to be using Node.js. If you are familiar with Fastify, so we're going to be using the Fastify framework to write instead of Express. We're going to use Fastify. I mean, Fastify is an amazing tool, right? So let me just share the link to Fastify. Fastify. So if you haven't tried Fastify, I mean, I think it's an alternative to Web Express JS. If you're using Express, I mean, why are you using Express? I mean, this Fastify. I mean, it just makes life easier. So Fastify, so you can check it out. Awesome. So we're gonna be writing our server with Fastify, and it has support for WebSockets. So why not? So without no further ado, let's create our first line of code, and then you're gonna how fast we're gonna write it, because now we don't have to do any back and forth. So I'm gonna create a new folder. Make the allow drawing bullet. Awesome. So I just created a folder really quick. So let me share my VS Code, and then we can start coding. So the first thing I'm gonna do is replace my screen to my VS Code. Awesome. So now I have my VS Code. No, right? You're excited like me. So let's quickly start coding. So now we're gonna have to client and the server, but now we're gonna write our server first, and then we're gonna be using Postman to test it really quick to make sure everything is working as expected. So now let's say server, and then now we have our server. We're just gonna say npm init coming hide. Come on, don't ruin it. So awesome. So we're gonna say, I'm trying to bring up my terminal in VS Code so you can see everything. Is it visible? Awesome. Now we're gonna say npm init. No, let's go to server first, and then let's just initialize it. No. Okay, I think we have a comment. Yeah, VS Code time. What happened? What? Am I visible? Oh, sorry. Okay, I think I'm back. My screen is not showing. What's happening? Come on, Restream, not now. Not now when we're ready to go. Stop sharing. Okay, let me do it again. Awesome. So we're back. So now I have my package.json initialized. So what I want to do is create index.js where we're going to write our code, index.js. So what I want to do now is first ensure it's working. Let's just console.log hello. So we're going to use Nodemon real quick. I mean, if you know any alternative to Nodemon, kind of blurry, really. Is it still blurry? Okay, let me see if I can zoom in. Is it still, how is it now, Mohammed? Is it better? Is it better now? Okay, let me know if it's better. So I try to zoom in a bit. So the first thing we want to do is use Nodemon, so we don't have to like quit our server and restart it every time we make a change. So we're going to say npm install Nodemon. Still blood? Oh my god, what's happening? Okay, let me try to confirm it on YouTube. Oh, not now. Not now when we're able to have fun. Oh my god. I don't know why it's blurry, if it's me or stream. This is, how to fix this? Oh my god. But can you still see it? But can you manage to see it, Mohammed? Okay, cool. So awesome. So we're gonna have to manage. Please manage with me. I don't know Restream. I don't know. It's so complex for some reason. Just does some shit times. So yeah. So we have Nodemon installed. So we just have to like update our start script. Just say start Nodemon index.js. So we can then run npm start. Yeah, so we have it running. So next thing we have to do now is go back to, let's pick our terminal. So now what I have to do now is install Fastify and the necessary packages we're going to be using. So we're going to be using Fastify. We're also going to be using the AsyncAPI parser to pass our AsyncAPI document. And we're also going to be using the AsyncAPI validator to validate incoming messages against our AsyncAPI schema definition. And then we're also going to use one more tool, which is AJV, which is used for validating JSON schemas, because AsyncAPI validator doesn't only validates incoming messages, but it doesn't actually validate incoming query schemas, like the one we're going to use to validate the kind of information users are providing when trying to connect to our server. So we're going to use AJV for that. So let's just get started. So we're going to have to install npm install at AsyncAPI parser. We're going to say we're going to install at Fastify WebSockets. Because we are using the Fastify, we're going to be using WebSocket for Fastify. So we need to install the Fastify WebSocket support. So Fastify /WebSockets. So we have to also install the Fastify package itself. Fastify. So we also have to install the, I said earlier, we're going to be using the AsyncAPI validator. So we need to install the package itself, AsyncAPI validator. So we also have to install AJV, because that's the one we're using AJV too. And it's a package, right? But I mean, it's cool. So I'm not the one writing it, already exists. So just install it. So we have the parser, we have the Fastify WebSocket, we have the Fastify package, we have the AsyncAPI validator, and we have Node. I think that's everything. So let's just install them. Oh, so while we wait, if you're still live with me, and yeah, if you have feedback from me, I respect constructive criticism to help me make better live streams. Please feel free to provide it also to me on this live stream. And yeah, I was hoping this live stream happened during Halloween. Maybe I could have came out better, scary. Hopefully maybe next time. Okay, now we have all these packages installed. So now what we want to do now is start writing our code, right? So the first thing we want to do is import the necessary things, which is Fastify. So we have to set up Fastify first. That's the most important thing. So the first thing we have to do is import Fastify. Fastify, not faster. So we have this one, not that one. So import Fastify, and then we have to then import the Fastify WebSocket. WebSocket from Fastify. WebSocket. Fastify. WebSocket, right? So we have this one. So now we have to quickly Fastify to make sure to get it up and running. Not to do that, you just have to also first let's initialize Fastify logger just to track all those little details. Const logger. I'm sorry, Fastify equals Fastify instance of logger false. But then we cannot just say Fastify instance where we haven't defined initialize Fastify itself. So what we want to do now is say Fastify route. So I mean in our AsyncAPI spec, our AsyncAPI document, I mentioned we are using the main the initial part as our only channel. So we also have to make sure that's always in Fastify. We want to say Fastify route. So you can, if you want to learn more, I shared a link to Fastify website, so you can go through it and then learn more about how to set up Fastify API, also for WebSocket support. So we have Fastify.route. So we have to define a method. Just we're gonna say get. But I mean, this looks like we're defining an HTTP, right? Well, it's WebSocket, so we'll say the URL, which is what we're also using in our AsyncAPI channel, which is the base part. And then we're going to say WebSocket true. This is important because in REST, we want to connect using WebSocket. So we have to pass the WebSocket property, enable it by saying WebSocket true. And then the next thing we're going to do is say handler, right? So handler, which is the whole where you can run the logic you want to run your business logic. So we're going to say handler. We're going to say handler is a function that just console.log lower, right? So we have the Fastify routes, but then we have to do some sort of listen. So we can set up Fastify. We can then say Fastify.listen, which is just like, if you're using Express, so you're basically familiar with distance. So it's just mostly the same flow, if not the same. So Fastify.listen, then we define the ports. Port 8787. Don't forget, this port we specify is also the port. If I switch to our studio, it's also the port we are using here, right? See, localhost 877 for our development server. So we have to use that same spot, that same port, right? So let's go back to VS Code. Window. Yeah, back to VS Code. Now we specify the port we're going to be listening at. And then we're going to listen for catch errors. We want to catch errors. And then we're going to say if there's error, we just want to say Fastify that log it, because we already enabled the logger, so we can basically just take advantage of the functionality in Fastify. So we're going to say Fastify.log.error, and then we're going to log the error, right? So I mean, dots not, and then we're going to log the error, right? And then we're going to exit the process. And to do that, we're going to say process.exit one. It's just so we don't want to keep the stuff running. So now we have this. I think this should. Am I? Oh my God, I think I'm missing. Oh, I lost my connection. Oh, so sorry about that. I'm gonna share back. Okay, awesome. So I'm so sorry about the background noise still happening, construction going on. So yeah, so we have an error. It says module not found. Did you mean to import blah 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 blah? Okay, so I think the reason why it's not working is basically because we enabled WebSockets, but we didn't actually import it, right? Because if you see WebSocket true, but we didn't import it, so we have to fix that. And in order to fix that, we have to register WebSocket in Fastify. So we've imported the WebSocket, so we just have to say await Fastify.register WebSocket, then WebSocket instance, right? So when we save it, oh, it's still crashing. Why is it crashing? What's this? No. Oh my God, it's a mistake. So it's saying drawing to a. That's an ES model. What are we doing? Is it not supposed to work? So if you see, we have an error because we need to extend our package.json to support type of model. Sorry for that. I missed that. I would have that. So we have our WebSocket connection instance initialized. So how do we test it? So I'm going to bring up Postman real quick and then make a request. Postman WebSocket, and then connect. Awesome. So it's working, right? So you see, what I did is go to Postman, and so let me just show you real quick, right? So shouldn't look as if I'm doing some magic. I'm not smart enough to do magic. So let me switch quick to Postman. Awesome. So now that we have Fastify set up, so what I basically did is let me disconnect it. So what I basically did is go to Postman, right? So by default, when you go to Postman, Postman would, select HTTP, right? But I'm not doing HTTP, I'm doing WebSocket because I already have the WebSocket package like registered in Fastify. So I just have to switch from get to, I'm sorry, not get, like HTTP here to WebSocket, right? And then I just have to like pass the local host. And when you're using WebSocket, you don't just say localhost. So you have to like pass like WS to say it's WebSocket instead of saying on HTTP where you have to do HTTP, right? But WebSocket you have to do WS. And then once I do that, I then see connect, right? So I just have to like connect. So when I connect, connection was initialized. So localhost, blah 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 blah, right? Awesome. So we have our WebSocket connection work. So you can see if I go back. If I go back to VS, right, you can see I said killing me. I chose the wrong day to this train. I hope it's not really that bad for you folks. So next, what we want to do now is this. What we want to do. What do we want to do? Now we have the whole route and everything set up for Fastify. Now we have to start the connection, right? So the first thing we want to do is class to manage our WebSocket connections. So let's do that here after this one. Now let's create a class called WS Manager. So WS Manager, which is basically a WebSocket manager. So create a class, then we say constructor, assign this, right? So in the constructor, we want to manage connection, right? So we're going to have different people connecting to our WebSocket API after server, rather. So now we need to like manage these whole connections. So I mean, if you want to, you might want to persist this whole data or something, but in this live stream, we're not going to do that, right? Because we're not going to connect to any database or something. So we're just going to do everything in a single run. So once we quit our server, we're going to lose all the sessions and stuff. So now we have to, in order to like manage sessions or connections, so we have to create something like to hold the list of connections, right? So we're gonna say this dot connections equals to, we're gonna use a map, right? I mean, it's easier to use a map because then you can then set the key for each connection as a socket ID, the socket itself, and then save the property. So we can easily retrieve connection based on the socket ID. And also like, I mean, it's also faster, right? So when they say create a new map, so now we have this one. So the next thing we want to do now is how the handlers function. The first method we want to do is the one that helps us add connections, right, to these subconnections object we have, right? So now what we want to do now is create our first handler, right? Which is basically add connections. So we want to first add connections. So our add connection is going to take two properties, right? It's going to take the socket and the user, right? So because initially when we try to connect when users are trying to connect to our WebSocket server, don't forget we are requesting for the username and the color, right? So that's what we're going to do. We're going to take the socket, the socket connection. Oh shit, this is really bad. Really, really bad. I can. It's as if they're eating it in my ear. I can't stop them. I'm sorry. So we have the socket and then we have the user, right? So those are the two things required. So what happens when we call this function, right? So we want to store it. We want to store the users, right? But then we also don't want to store users with the same name, right? So we want to make sure all the users we are storing are different users, right? So, oh my god, it's killing me, bro. So we're gonna manage. So we have to then, of course, we want to ensure that the users we are storing are unique, right? Users, unique colors. So we're not storing users with the same colors, right? So now what we have to do now is let's extract, because this is going to be an object, right? Because this user we are returning, the user we are passing contains the username and the color. So first, let's just extract. So we're going to say const username, and color, which is coming from the user object. So what we want to do now is make sure like the user doesn't exist already. So we have to first check the size of the connections to see, because if the connection is empty, then of course we don't have to like do the check, right? We can just pass in the user. So we're going to say, create an if statement and say if this connection, the size, because I mean that's one of the advantages of using map, right? It's faster to retrieve objects, check the map and stuff, right? So we can say object of size. So we want to check the size of the map, right? To see if it is empty. So we're saying if connection the size is greater than 0, basically means like if it means like there's a connection. So what do we want to do, right? We want to check like the connections for. We want to connections to see if we have a user with a particular username. So to do that, so we're just going to iterate through the connections real quick. But before we do that, right? So let's say if connections, right, greater than 0, we're going to leave it. We're going to say console.log. There's a connection for now. Connections exist, right? So if there's no connection, we just want to set connection by saying this connections.set, because we already have access to this, right? So we just have to like set it, right? So when I say this was connections was set, so what I mean, right? We are setting connection the socket as the ID of the user and then the user object. Awesome, right? So we're gonna do this, and now we have this one for the connection, for adding connection, right? But then what do we want to do? We still have to do something, right? Because we're saying whenever we initialize a connection, we go back to AsyncAPI Studio. Let's go to the studio to see our API file. Now we are saying here on connect, right? So when a connection is established, right, we want to send out like this message. Sorry, not this one. This one, right? An handshake, right? That's initialized like, oh, there's a successful connection. So as we can then see in the payload, this is what we are sending back to confirm their connection was successful. So we have to somehow do that. So for now, we are just going to set the connections. But then what we want to do now is go back to the handler in our Fastify and then set up the connection first, because it won't work right now. So we need to first set it up. So what we want to do now is say in the handler, let's get rid of this console.log. So what we want to do is say handler, we have to expect two things, right? The sockets, retrieve the sockets. So whenever a connection is established, we want the sockets and then the. So now let's see what happens. So let's console.log this socket. See what happens. So if I do Postman, so I'm not going to show Postman in terms of switching. So basically what I'm doing, I've showed it connect. So when I try to connect to this API server from Postman, see what happens. You see, I get connection. This whole socket object and stuff, right? So which means there's a new connection also. So what I want to do now is instead of console.log in the whole sockets, so I want to add the socket to this connection we've created, right? I need to add it to this add connection. So what I have to do now is say, instead of saying console.log connection, I can then say, oh, when you initialize a connection, we need the username and the username and the colors, right? So what we have to do now is say const user equals request, because now because in the handler we have the request access to the request, right? So we can say then request just query. Sorry. Okay, request, yeah. So you can say request just query. So let's console.log the user, let's see. And we are not gonna get anything, right? You see, we get undefined. So we get, oh my God, I didn't switch to VS Code. Oh no. Oh no. No way. Okay, so what I basically did before I forgot to switch back to VS Code is in my handler that I defined earlier, so I tried to have access to the request query parameter from the connection when I initialize connection. And so when I console.log the user, which I'm saying from request.query, oh sorry, query equals to user. So when I connect to my server, you see I get an empty object, right? Because yeah, I'm so sorry, Mohammed. I forgot to switch back. So thanks for the note. So what I'm basically doing now is I try to have access to the query parameter when a new WebSocket a new WebSocket connection is made, right? But then WebSocket from Postman, it is empty, right? It's an empty object, right? Because I did not provide any username, any query parameters, right? So, but if I provide one, let me disconnect. Come on, I don't know why are you stopping? Let me share, okay. Awesome. So if I create disconnect, now I create this. So what I'm doing behind this scene in Postman is I'm trying to pass a query parameter, right? So if I connect now you see, now instead of returning an empty object, it is now returning the username and the code, right? Because that is what I'm passing when I create the connection. I'm passing the username and the code, right? Sorry. So, but then it makes sense. It works, but it still works when it is empty, right? When I did not provide anything, when I refuse to provide params, and I try to connect, it still works. But the whole idea is it shouldn't work, right? Because in our AsyncAPI document, we said it shouldn't work, right? So in order to establish a connection, you have to provide the username and the color, right? But currently it's not working. So in order for us to like make have this functionality in our server, we need to use something WebSocket calls, Fastify calls pre-hook validation. So we're going to do that. Pre-validation basically means before a connection is established in Fastify, you want to do something, right? Before the connection is established. So we're going to use the Fastify pre-validation. Fastify pre-validation, right? It's an asynchronous function that takes request and response, request and response, just like basic WebSockets. Sorry, Express. So awesome. So now we have so if I console.log hello, right? So when I establish a connection, see what happens. Postman. Connect. You see, hello comes first before user, right? Because this function runs and it's been established, right? So which basically means I can do my pre-validation here, right? So I can handle the whole, connection instance here in my pre-validation method. So, and that's basically what I'm going to do. So in order to do that, what I have to do is say, we're going to say user, we're trying to retrieve user from the query parameters. So we're going to say const user equals request dot query, right? So we have the user request of query. So let me get rid of this here. And then let me log it here, console.log the user. And when I when I call Postman again, when I connect on Postman again, you see now it's returning an empty object because it's empty. So we're going to do some validation. We don't want it to connect. So in order for us to not make it connect, we have to do something cool, right? So the first thing we want to do is import our AsyncAPI document here, right? So we're going to say new file, AsyncAPI.yaml. right? So we're going to go to Studio and copy our document. The document we've created, we are going to like import it here. So what we're going to do now is go to Studio and retrieve this document. Studio, where's Studio? Where's Studio? Somebody find me Studio. Cool. So Studio, I paste it. So now this is my AsyncAPI document, right? The one we both created on Studio, right? So now we want to use it, right? So we have everything here. As you can see, I'm also going to share a link later after the Studio where you can find, after this session, where you can find the source code. So we have everything we've created for the past 2 hours here, right? So now we want to use it, right? So in order to use it to validate our connection, what we have to do now, we have to save this. We have to use the AsyncAPI parser, which is one of my favorite tools. So parser basically lets you pass your AsyncAPI document. It helps, so it validates your AsyncAPI document to make sure it's a valid document, and then it gives you the ability to access anything in your AsyncAPI document. So you can access the messages, you can access the channels, you can access any part of the AsyncAPI document, right? So what we have to now do is import the AsyncAPI parser. So not to import it, we're going to say import parser, and then because we are passing it from file, I say from file, from AsyncAPI parser, right? So basically what this does is the parser, of course, the parser itself, and then from file, because it's supposed from, you can actually, if you're using the AsyncAPI parser, you can pass document from URL, you can pass document from file. So but we are passing from file because we already have the AsyncAPI file here, right? So what we now have to do to use our AsyncAPI parser, we have to create a new parser here. Say new parser, new instance of our parser. Right, so now we have created, now we have access to parser. So how do we pass our AsyncAPI file? So basically just AsyncAPI file was saying, create a const, because the AsyncAPI document, AsyncAPI parser, when you pass the document, returns either an error, basically saying your AsyncAPI file is invalid, or passes the document if it is valid, right? So, but what we need access to is the document. So we're going to say the document. Then we're going to await the from file, because it's an asynchronous operation. So we have to wait for it to like pass. So we're going to say pass. Then we're going to say parser, which is this parser we've created here. We're going to pass it, and then we're going to pass the file, right? And we're going to say ./AsyncAPI.yaml, right? So we've passed it. Now let's see if it works. So let's console.log the document to see if it works. Moment of truth. It doesn't work. Something's happening. So we have an error. Please, the pony code mode is deprecated. Please use a user land. Is this error from us? I hope not. Oh, we are missing one thing, right? So if you go to the AsyncAPI parser, let me share a link quickly. Parser. Async parser. So you can use the AsyncAPI parser here. Right, so share the link to parser. So we just have to, we are missing one more thing. We just have to say .pass, right? So if we fix it now you see it works, right? So when I console the documents, it basically gives us access to our document, right? So we are going to be using this to validate our user data. So now what we have to do now, we have access to the document, right? Awesome. So now we have to go back to the our pre-validation function that comes with Fastify, and then we are going to do, so what we're going to do in this pre-validation part is do this authentication aspect, validate the kind of data we are receiving from the user when the user tries to connect our WebSocket server before anything else, right? So that's what we're going to do. So what we're going to do now is use the AsyncAPI parser to have access to the type of message we are expecting, right? And then validate it against the connection. So in order to do that, what we have to do now is pre-validation, right? So we're going to say AsyncAPI bind. And I mean, if you've been following us before, I mentioned how we use the AsyncAPI binding feature in the to provide channel specific information for our WebSocket server. So what we have to do now is let's get rid of this for now. We're going to say a new const, right? We're going to say, let's just say, what can we call it, right? Let's just call it WebSocket bindings. So what WebSocket binding is basically doing is we are trying to retrieve this information. So we're trying to retrieve this information here, right? So we're going to be validating the data we're receiving when a new collection, when a client is trying to connect our server, we are going to be using that, we're going to be validating that schema or that information against this schema, right? So in order to do that, we are going to have to retrieve this using the AsyncAPI parser. And then we're going to say documents dots now. You see, awesome. We have all these methods available to us. Like we can access any part of our AsyncAPI document using AsyncAPI parser. Right. So what we want to access is the AsyncAPI channel bindings. So we're going to say document.channels, right, which is going to list us all channels. And we're going to say channels.get. And then what channel are we retrieving, right? So we're retrieving we have one channel, which is the root channel. So we're going to say the root channel. So we're going to get the root channel. So if I log it like this, WS bindings, let's see what happens. So sorry. Okay, let's see. It's saying the same error now. Why is it that's minus? So we are getting an error. Why are we getting this error? We are stuck again. The Punicode mode is deprecated. I mean, we have access to documents, right? So we have an error. I don't think this error is our miss. I think it's coming from parser for some reason. So let's see why it's not working. Okay, let's just see. But we have the document, right? I mean, if we console.log the document, from file, and we pass the parser. Is not working. So the log document. So why are we getting this? I don't know why we are getting this error. But it happens when we import parser. So if I remove parser, so it happens when we import parser. So I think, so you see why it keeps getting this error. So we're just gonna use it like that for some reason. I don't know. So let's continue. So we're gonna initialize the connection. We're going to say, so channels, right? So let's log the console.log WS bindings, and we're going to see the list of channels available. available, right? So when I go back to Postman and connect, you see, so I have access to channels available. So I only have one channel. So it says address, main component channel, just like the channel we defined in our AsyncAPI, right? So what we're trying to reach now is the channel bindings, right? So you just have to say channels.get. Now, all of these methods are available because I'm using this AsyncAPI parser. So all of this comes out of the box. I'm going to say AsyncAPI.get. I'm going to get the root channel, right? And then I want to get the bindings, right? The channel binding. So if I save this and connect again, you can see now it returns the bindings. So many return. Okay, so now you can see we have the bindings here. So now we want to access the query bindings, right? So now we have to do bindings. Sorry. Right, so we have to say bindings, just get the WebSocket because we have only WebSocket bindings, and then we're gonna say just get the value, right? So to retrieve the value. So now when we log WebSocket bindings from Postman, you see we have access to the bindings. So what we're gonna do now is validate this data that is coming when a connection is about to be initialized against these query properties. And then we're going to be using AJV for that because AJV validates JSON schema, right? So that's what we're going to do. So we are going to import AJV. So we're going to import AJV from AJV, and we're going to create a new instance of it. Const AJV equals new AJV, right? Awesome. So now what we want to do now is say, go back to our pre-validation hook. We want to log the user, right? Okay. So what we want to do now is console.log instead of bindings. We want to have access to the user by saying request those query parameters. We want to say const user equals request dot query, right? And that's how we have access to the user. So if we log this now, like I done a couple of times already, if I log the user and I connect to Postman, through Postman, you can see like it returns an empty object, right? Because I didn't pass any query parameter. So now what we want to do now is let's just create a function outside here. Let's just call validation or whatever we can just call it. Create a function. Let's just call this function validate payload. Validate payload. So what this function is going to basically take is it will take the data you want to validate and the schema you want to validate the data against, right? So we're going to say schema and then payload. So now because we are going to be using AJV to validate the schema, because this is not, we could have used this validator, but the AsyncAPI validator only works for messages, right? Only AsyncAPI by messages. It doesn't work for any of payload you're trying to validate. To only validate message payload. And I know we've been on this session for so long. I'm going to try to like wrap everything up in an hour. So please bear with me. So now we have this function that says validate payload. So what I want to do now is validate our query parameters that is coming when initialize the connection with our WebSocket server against the schema we've defined in our AsyncAPI document, right? And you can see now, like we're not just using our AsyncAPI, AsyncAPI to only provide documentation for our API. We are also using it to validate payloads in our API, right? So now what we have to do now is say this takes schema and payload as properties, and what we want to do with them now is say I'm really thirsty, guys. So we're gonna say create const. I mean, if you don't know about AJB, you can basically check it out on NPM. They have really amazing documentation. So we're gonna say const say validate is equals to ajv.compile. So what ajv.compile basically does it's like it wants you to like pass the schema you want to validate your payload against. So it's gonna check. I mean, it has to be a valid JSON schema, right? So is ajv.compile, then we are gonna pass our schema to this ajv. So this validates because if it is valid, then it's right. So if if it is a valid JSON schema, it will work. So what I want to do now is say now I want to create a new constant is valid. So what this is going to do now is this is the one we're going to use to validate this schema with our payload, right? So we're going to say validate. Oh, sorry. No, this is valid equals to validates payload, right? So now, because if this works, then we're going to have access to this validate, right? Then we are now, what we are not doing is we're now validating this schema, our payload rather, we're validating our payload against this schema to make sure we have correct data, right? So what we're going to do now is say return is valid. So is valid can either be true or false. It's a boolean, right? So if it is true, which means it's valid. If it is false, it means oops, it doesn't work. So now we're not gonna use this validate payload. We come to the pre-validation handler here. We're not gonna say now we have access to our schema, which is coming from the AsyncAPI spec, right? Because with the help of a parser. Now what we're gonna do now is say create a const, right? Saying is valid, or let's say is valid schema, or is valid payload, which is going to call basically this function, right? Validate payload. Then what are we passing? So it takes two arguments, like schema and the payload. So we're going to pass the WebSocket bindings, which is these bindings we are retrieving from the AsyncAPI document. So we're going to validate our payload against that binding. So what is our payload? Our payload is basically request query parameters, right? Request query. And then we are going to console.log is valid payload, right? Now let's see what happens. If it's going to be true, if it's going to be false. So now let's try to, pass an empty, like let's just try to initialize a connection without passing any query parameters, right? And let's see what happens. So I'm going to go to Postman. I'm going to try to connect without passing anything. Just try to connect to my server. See what happens. Oh, it didn't even connect. It didn't even connect at all. And why is that? Is it because we're already doing this? Let's see. So it's really awesome, right? This is, I don't know how this pre-validation hook works, but for some reason, immediately I try to validate this payload, right? It doesn't even connect at all. Like the connection doesn't even work. So let me show you my Postman. Replace screen. Postman. See, so now I'm trying to connect. Let me disconnect it, right? Now I'm trying to connect without passing anything, right? And I try to connect. See, the connection did not even, it doesn't even work because in my pre-validation hook, the data being returned is false, and for some reason it's just picking automatically, like it's not creating a connection at all. And that's one thing I love about the pre-validation handler in Fastify. So what we're gonna do now is let's try to pass a valid like JSON schema, right? A valid object or a valid query parameters, just like the one our AsyncAPI document expects us to. So let's pass this one. We want to say name James, color red, and then we're gonna connect. But it doesn't work. So why is it not working? So let's try to debug why it's not working. Let me go back to VS Code. Okay, back to VS Code. Let's try to figure out why it's not even working, even when I pass the correct data. Then let's see. So So let's console.log request.query. So we have, oh, it's not, yeah, I mean, it's not still working because if you see, we are passing color code. And our AsyncAPI document doesn't expect us to pass color code. It expects us to pass color. See how this is amazing? Like even our server, it's even easier for us to build our WebSocket server based on our AsyncAPI document, right? So this leaves room for no mistake. Like your server will be well written, right? So the whole infrastructure is based on our AsyncAPI document, right? Infrastructure as a code, and that is why it's not even working. So now, if we go out to VS, I'm sorry, if you go out to Postman and correct color code to ordinary color, because our AsyncAPI document is expecting us to pass color, not color code. So color, let's see. So we have the username, we have the color red, and then it's not still connecting. Oh, now that's weird. That's really weird. Now let's see why it's not working. Look at document. So we have username and we have color, right? So let's see why it's not working. Now let's see if it is because something is happening in our function here. So let's try to console.log is valid to see what's happening. Postman. Okay, let's see. Now let's log this one out. Let's log this one out. Now let's see. It's not still logging. Oh no. Oh no, what's happening? So we pass the schema. Oh my God. I made a mistake was coming from me because when I passed the schema, I was passing the schema with a query, right? So the AJB was actually validating this whole thing, right? Meanwhile, it should be validating only this part against our payload, right? But then it's validating the whole schema, including the query. So it was expect property query, right? So we need to fix that. And we shouldn't be passing the query. So let's say schema.query. Let's see if that would fix it. Yeah, that fixed it. Awesome. So the mistake was we were passing the whole structure from our AsyncAPI document, including the query parameters, the query property, no, the query key, which is not supposed to be. So let's fix that here. So WebSocket bind. So we are going to be passing WebSocket binding.query. Awesome. So when we connect, it works. Yeah, it works. So now we are validating properly against our schema. So now let's make some changes to make sure it doesn't work. So let's change the color back to color code to see. And when we console.log, see, it doesn't work. False. Awesome. So now it's working properly. So now let's continue. Say console. Let's get show.log. Awesome. So now let's console.log is valid, right? It's valid payload to say is a payload valid against our AsyncAPI schema, AsyncAPI bindings, or the binding schema, of course. So let's connect, right? Now it's false because I'm passing. Let me console.log the query also, so we can see request.query. So connect and see now we have username and color code, but then we check is the payload valid? It says false because it's not valid because it's not expecting color code, it's expecting color, right? So now what we're going to do is extend our pre-validation method to have more capacity. And to do that, we just have to say in the AsyncAPI, I'm sorry, in the pre-validation method, we just have to say if it is valid or if it is not valid, rather. So if it is not is valid, so which means if when we validate our payload against our scheme true, it is false, we don't want to establish the connection, right? So what we are going to do is then say await reply or response in this case. Let's just say rest.code, it's one dot code. We're going to, let's say, a for one, which says the send, you are not authorized. Say, you are not authorized to rest. Right? So now let's save it. And then let's try to initialize the connection with Postman this time and see what's going to happen. So when we try to create a new connection, we get a, so let me share my Postman to see what happens. Cool. So this is Postman. Now I try to connect to my WebSocket server with the wrong headers, with the wrong query pointers, right? So now I pass username, then I pass color code. But in our AsyncAPI specification or our AsyncAPI document, we are requesting username and color, not color code, right? So when I try to connect with the wrong query parameter, you see, it doesn't work. It says unexpected server response 4.1, you're not authorized, which means, well, we have this validation in place, right? I mean, straightforward. We're not even doing anything like crazy. We're just basically validating what the message or the data that is coming when you're about to connect our server, and then we validate it against our AsyncAPI document, right? And that's just it. So when we correct this and just say, instead of color code, we just pass color, it works. Now we are connected, right? So that's awesome. So let's move on. Now we have the how validate. So what do we want to do now, right? So we have this validation working as expected. So what we want to do now is in our handler, which means immediately connection is initialized, we want to add that connection to the list of connections, right? So what we want to do now is say const user, which is basically coming from the query, request.query, and then we're going to say, so we have to call this add connection function method, rather add connection method, right? So now in order to do that, we're just going to say WebSocket manager dot add connection sockets. So I mean, it requires two properties: the socket, as you can see here, the socket and the user, right? So we're going to say socket and then the user. Now let's see if that works. So if we go back to our add connection, let's console.log the username to see. Now let's create a connection. Let's connect to the app. No, I didn't change back to VS Code. I just keep forgetting. I was so in the mood. Okay. Awesome. So back to VS Code. So I wasn't sharing my screen. So what I did now is, because we have the whole validation, pre-validation working, now we just have to, once the connection has been established, we want to add connections to the list of connections, right? So now what we just do is call the add connection method that was defined in our WebSocket handler, and then we just pass the connection and the user, right? What we do now is come to the add connection here, and then just console.log the username to see if we're going to get the username. And then I'm going to make the request in Postman. Did it work? No. And why is that? Let's figure it out. Let's see. We have a socket, we have connection. Let me comment this out to ensure that's not why it's breaking. Okay, so why is it not working? So we have the trying to add the connection by saying WebSocket manager, right? That add connection. I think it's a typo somewhere. Okay. Let's see why it's not working. So we are having an error. Let's see why. Oh, so we have the connection. Say the constructor. This is a connection, and then we define the add connection method. But it's not working. So if you're still live with me, let's try to figure out why it's not working. The add connection. So WebSocket manager to add connection. It's a function, right? Are we missing like a typo or something? This is tricky. Sockets and the user, right? But the sockets and the user. But when we try to connect, it's not working. This is the problem with live coding. Something seems to always break. Okay. How? So the reason why it's not working is because I created this class, but I never like initialize it. So I don't know why I was expecting it to work. So maybe because I'm tired. So yeah. So what I'm gonna do now is say um, come here, and then I'm gonna say const WebSocket manager. Equals to new WebSocket instance, WebSocket manager instance, right? And then I'm gonna say the WebSocket manager. I'm sorry, I'll have to move this up a bit because I can have access to it from here. I'm gonna say call it here, right? And then I'm gonna say WebSocket manager, this one, not this one. I was calling the class name itself, not the initialization of the class. I'm gonna say WebSocket manager that add connections to work now. So if I come back here, save it and connect. Awesome. So it's working. You can say we have hello. So we can get rid of this hello and back to this. And then let's consider log the username. Let's see when we connect, we have the username, right? James, which is, what do you mean James? Which should be James, right? So I'm gonna say James and connect. But then I got an error saying connection exists. I mean, not an error because that was what I was expecting. So now we have the name James. So let's disconnect and then restore server because I don't want that to happen. Awesome. So now let's connect. Now we have the name James, right? Because after the whole pre-validation stuff, everything is working. We have the James. So now when we connect the name, so when we call the user website.add connection, so what we're doing now is if the connection, like if the list of connections is empty, then we just basically want to add this connection, right? So if not, we want to do something. So if the connection size is bigger than, like, if there's already a connection in the connection list, we want to check if we already have a connection or a client with the username or with the color, right? So in order to do that, we have to do some logic. So what we're going to basically do is iterate through the list of connections, and we're going to basically do that by saying, okay, let's just test this out. So if I try to create a new connection using the name Mohammed with the color blue, let me connect. You see, then it will say connection exists, right? So connections exist. So let's say connect, and then you see we get the name Mohammed, but then we get the connections exist, right? So, but what we want to do now is we want to go through the list of the connections to ensure we are not, duplicating users. We are not creating users that already exist or colors that already exist, right? So what we want to do now, and we're almost done with the server, right? So what we want to do now is say iterate through the list of connections by saying for const connections, connection of connections of distance connections. So we're iterating in the list of connections. So we want to check if so the first thing we want to check is the username. So we're going to say if connection dot username, right? So if connection dot username, so we also want to convert it to lowercase just to make sure it's getting everything correctly. Lowercase dot to lowercase. So if connections like in the current index or the current iteration of our connection, we want to check if the username is equal to the username where the client trying to connect is. So we want to say if username of connection equals username, which is this username, this one here, this username dot to lowercase also. So we want to do something, right? We want to console.log. Oh, user already exists. Console.log. User already exists. Awesome. So now let's try to connect with the name Mohammed again. So let's see. So now we have Mohammed. So now let's disconnect it. Sorry. Let's copy this and try to connect again. So it's not connecting. Why? Okay, let's see why I'm connecting. Connection. Oh, sorry. I was saying no, just values rather. I forgot to add the values. I was trying to iterate something that is not possible. Dot values. So let's try to connect. So let's connect Mohammed. So Mohammed is connected. So now let's try to connect Mohammed again, like a new connection with the name Mohammed. And let's see what happens. And then you see we get an error saying a log message rather that says user already exists, right? So you know what we want to do? We want to send a message back to the connection, to the person connecting. So what we're going to do now is say, if a user exists, we're going to say socket dot send, because we have access to the socket here, right? We're going to socket dot send, just on the stringify the message we're sending. So we're going to say type error text. Let's say user with this name already exists. And then we're going to say the timestamp. We're going to say new date, which is like the current date. Dot to ISO string. So now let's try to connect. And then when we try to connect with Mohammed again, so let's connect with Mohammed. Connect. So, and then let's try to connect with a user called Mohammed again. And then let me show you real quick my VS Code, my Postman application. So now let me restart the whole. So now this is what is happening. So now I try to connect with the username Mohammed and color blue. So when I connect to my WebSocket server with this, it works, right? It's connected like expected. But when I try to connect the same person again, username with Mohammed, you see, I get a message. I mean, it's good because we haven't we're not done with the logic, but then we get this message that says type error text username already exists, right? So which means it's working as expected. So what we want to do is extend this by then saying connection. So when we send this message, we want to close the socket, right? We don't want to establish the connection. So in order to close it, we just want to say socket. Oh, sorry, return socket.close. So now let's do the same thing. So what I did now is if I share my VS Code, so what I did here now is after I send the message back to the socket, I return the socket that's closed. So I mean, I want to close the connection, right? I don't want to establish this connection. So if I go back to my VS Code, if I go back to my Postman, awesome. So if I go back to Postman and I try to establish this connection again, like I did before, so I disconnects. So when I do the same username, let's see what happens. You see, it doesn't connect. Like it disconnects. So and I get the error. I get the message, right, that says, "Oh, user with this name already exists," right? So, and I get the connection closed. So the connection doesn't establish. So now let's do the same thing for the color. So we can just basically copy this and paste it and replace it with color. I'm saying instead of if I say else if connection.color. Oh, I don't know. I used to forget to change your VS Code. So what I basically did is I copied this whole thing, this one here, right? I just paste it here and then replace the properties, right? So instead of username, I'm going to say color. And then I'm going to say color. And then I'm going to say user with this color already exists, right? So if it doesn't exist, then I'm going to then add this connection to the list of connections here, right? So now let me run it again. Oh my God, I've almost spent 4 hours on this stream. I didn't know it was going to take this long, but yeah, but I'm having fun. So now let's run it again. Let's go back to Postman. Okay, so now I'm back on Postman, and what I'm basically doing is this. So I've now created a connection. Mohammed, it works. Let me try to connect again with the same person. It doesn't work. Now let me change the username from Mohammed to Ace. But then look at what is happening. The first connection I initialized with Mohammed has the color blue, right? But then Ace also has the color blue. So let's see if it's gonna work. So and I say send. See, it doesn't work because it says, oh, user with this color already exists. So you need to change the color. And then I have to change the color to, let's say, red. And then I send it. And boom, connection initialized, which is fun. So we've handled the whole connection establishment with our WebSocket server. So, but we are still missing one more when we had the connection, right? Because if we go back to our AsyncAPI document, real quick, let's go back to Studio. I don't know which of the studio are we using. Oh, I'm so confused. So let's see if it's this one. Okay, yeah, this studio, right? So if you go back to the studio, you know, we have this which one, operation, right, which says on connect. When a connection is established, we expect the client, whether we are connecting to the server, we are expecting this message, right, the number of connection and the connection status, right? Cool. So now what we're going to do is so what we're going to do now is to restructure what we've been doing to match what the client is going to be expecting, right? So we need to do it based on our AsyncAPI document. So what we will do now is go back to VS Code and follow the structure that we already have. So now let's go back to VS Code real quick. And then we are back in VS Code. And then what we are now doing now, am I showing the right one? Yep. Okay, no, I'm showing the wrong screen. Cut drawing, but okay, now I'm changing the right screen. So now what we're going to do now is, instead of sending this, because this is not the message we are expecting, the pattern for our AsyncAPI, our WebSocket server is expecting. So we need to make sure it's like what the person is expecting, right? So what we're going to do now is say, instead of saying type error, so the person is expecting two things, right? The person is expecting a number of connection. Num connection, which is the size. Oh, come on. So sorry. Awesome. So now the message we have to send back to this client based on our AsyncAPI document has to be the number of already connected clients and the set of the connection, right? So we are going to say number of connection, which is the distance connection size. So, and then the status, right? So the status has to be either 0 or 1, where 0 means no connection was established and 1 means connection successfully established, right? So we have to say status 0, right? Awesome. So let's just copy this and then do the same for this. Awesome. Now this is what we are supposed to send back to the client. Then if the connection was successful, we have to then basically do the same thing by saying socket.send the same thing, but number of connection I think it's connections, not connection. I mean, let me confirm real quick. Is it connection or connections? Okay, it's connection, no connections. Okay, so connection, and then we are going to say 1, right? So if we have successfully connected, we are going to say 1, but if we didn't connect successfully, we're going to say 0, right? So now let's save this. So now let's save this and connect again on Postman. Now let me switch back to Postman. Postman, I've been switching a lot, it's taking a lot of my time. Awesome. So now we're back to Postman. So let me real quickly connect. So now let me just say I'm connecting as Mohammed again. So we are getting an error. Why we getting errors? Okay, let's see why we're getting another error. Second the send is on Specification. Okay, why? Postman. So it's working, but when I say socket assign, okay, let me try to figure out why it's not working. Not now, come on. Oh, sorry. So it's not working because I was using size as a function. No, the size, not size as a function. The size. Okay, so I just fixed that real quick. I'm not gonna be sharing. So it's what. So now Postman back. So now let me connect as Mohammed. Oh, come on. The size, the size. Okay. Now let me connect as Mohammed. So I've connected as Mohammed. So you can see now we have the number of connection and the status connection, which is basically what we are expecting based on our AsyncAPI document, right? So we have number of connection 1 and the connection status of 1, because of course Mohammed is correct, right? So Mohammed has successfully established a new connection. Now, if we go to open a new connection with the name, okay, let's see, with the name Mohammed again. And let's see, it fails, right? Because we already have Mohammed, but then we get the correct payload, right? Because that was what we are expecting based on our AsyncAPI document. We get the number of connection 1, of course, so Mohammed is connected already, but then we get a state of 0, which means, oh, we couldn't establish a connection. So everything is working as expected, right? So now we have the whole thing functioning as expected. So we have the whole adding of connection working as expected. So let's go back to VS Code. We are almost done with the server. So let's create. Now we have the connection established. Let me reduce this time, mistake out of space. So we have a connection established, and now we have connection working. Now we've established connections. So the next thing we want to do now, after we've established a connection, is to create more method of removing connection. So whenever a user disconnects, we don't want to keep that connection, right? We want to remove it from the list of connections. So we're going to create a new handler called remove connections. So we have had connections. Now we're going to create remove connections. Remove connections. Connections, which basically takes the sockets as a parameter. And then we're going to say, so we're going to remove the connection by saying this does connection. Connections just deletes. I mean, because we're using map, so we have access to doing all of this really cool stuff now without actually iterating. So we have the delete, then we just have to pass the connection, right? Because we are using the connection as an ID. You can see here where we're saying set connection, and then the user, right? So we're going to remove based on connection. So remove connection. And then where do we call this remove connection? So we call this remove connection in the handler of our Fastify. So we're going to say sockets. So let's just handle the connection here. So whenever a client disconnect, we want to remove the connection. We're going to say socket.on socket.on close, right? On close. So we're going to say WebSocket manager just remove connection, and then we are going to pass the socket. So now let's see. I mean, we have to try it out, right? So let's do before we do this. So I'm going to connect as Mohammed, and I'm going to disconnect, right? And then we're going to say the size of our connection. Now let's say console.log this does connection the size, right? So I'm going to go to Postman real quick. So you're going to say the log here. Now let's go to Postman. So now I'm connected as Mohammed, right? Awesome. So I want to disconnect. So when I disconnect, you see, we get 0, because now when Mohammed connected, the number of connections were 1. But then when I disconnect as Mohammed, the Mohammed gets removed from the list of connections, which basically returns, gives us like 0, which means now we have no connections at all, which means it's working expected. So now the final part of writing our server is actually handling the message aspect, which is the fun part. And the handling the message aspect is where we are going to be using the AsyncAPI validator to validate our messages. Now to handle the messages, so whenever we receive a message, we want to handle it. We want to validate the messages against our AsyncAPI defined message schema. Awesome. So now what we're going to do now is go to our handler in our Fastify connection, right? So we're going to say, no, see, the way we have this socket.close on .onclose, we have the socket.onMessage also. So whenever our WebSocket server receives a message, how do we get it, right? So in order to have access to it, so we have to say socket.onMessage, right? On message, sync function of payload, which is a message we're going to get. It's a payload. And then we're going to do this, right? Awesome. So now let's consider the message payload. Message payload. Awesome. So I'm going to connect with Postman, and I'm going to send a message, and I believe we should get the message in the log, right? So let me remove this one because we don't need it. And then let's go back to Post. Let me go to Postman. Now I'm going to connect as Mohammed, and then I'm going to send a message called hello world. Hello from Mohammed. Now, if I send a message, I believe we should get it in the log. Awesome. But we are actually, we got a message, but it's not actually a human readable message, right? It's a buffer, right? Which means we have to, fix that. We want a message, not a buffer. So in order to do that, what we want to say is say this. So we want to say const message equals to buffer.from payload, right? So we need to change it, right? We're going to say to base 64, right? And then we're going to say pass it like to a readable string, right? To local, is it local string or to string? And we're going to say UTF-8. Now, if we console.log the message again, now let's see what happens. So, let me send this a message. I'm controlling and I send this a message. Now you see we get the message that we are sending from Postman as Muhammad, right? So now what we have to do now is to validate these messages against our schema, right? And in order to do that, we basically have to do this. I mean, this is like the final part of writing our server to make sure everything works as expected. So in order to validate this message, incoming message against our schema that was defined in our AsyncAPI document. So what we have to do now, so let's just write a function to validate these messages, right? So let's create a new function as after this one, as that says, create a function called message validation. Of course, then we have to pass the message. Whew, almost done. So message validation, we have to pass the socket. So the sockets are, and then so we define the socket. So we want to return an asynchronous of message. So the function, want this to return a function of message and the request. Okay. So what is happening? Oh, sorry, I was in a function. Oh, fixed. So what we want to do now is whenever we get a message, we want to try to make sure we're catching like the errors. So let's see if we have any error. We want to console.log the error. So this function we're writing is to validate incoming messages. So what we're going to do now is import the AsyncAPI validator. So we're going to say import AsyncAPI validate. Oh no, async. Is it AsyncAPI? AsyncAPI. AsyncAPI validator. I don't we imported it. I don't we installed AsyncAPI validator. I don't know why it's not suggesting it. Validator from we did from AsyncAPI validator. So what we're gonna do now, since we imported that, is we have to utilize it in the function. So in order to, AsyncAPI validator also like uses the AsyncAPI parser. So we also have like how much repeat the same process as we did in the parser to make it work. So what we have to do now here is to say let's say validator, or let's just say VA, just like in the documentation of the validator. Say we're gonna say await AsyncAPI validator dot from source, right? Just like the same way we're passing the parser from file. So let's say from source. So the same thing we are passing from here. So the source where the AsyncAPI document lives. So we just have to pass from source, right? Let's give it to YAML. And then we need to do one more thing. So one thing we didn't had that is basically required when using the AsyncAPI validator is the unique ID, which will be used to like retrieve messages. Let me just share the link to the AsyncAPI validator package so you can see how it's being used. AsyncAPI validator. So it also supports previous version of the specification, but we are using it for version 3. So awesome. So this is the AsyncAPI validator package. So what we're not doing now, so you can just go through it to see how it works. And so what we have to do is pass the message identifier. Let's say message identifier. Message identifier, which is just like the document requires us to. Unique ID. Oh, this has to be in an object, sorry. Awesome. So we have this working. So what we now have to do is go back to the WebSocket validation we were writing for our messages, for our message validation. So what we now have to do now is this. So the first thing we have to do is get the request URL. We don't have to code it. We can just basically get it. This is basically also the URL being used as the channel address, right? So we can just say const path name equals request.url, which is like we're only using the base path, right? We only have one channel, which is the root channel. So what we're gonna do now is say, now let's retrieve the channel based on the paths. We can basically just pass it, but I don't want us to add code anything. I want us to write it based on what we've written in our API document. So you can say the channel now equals to get channel address. No. Okay, so so what I'm trying to do here is, so what I'm trying to do here now is to retrieve a particular channel based on the address. I'm just going to write a quick function that does that. I'm just going to say create a function that says get channel by address. Oh, for the sake of time, I'm not going to do that. I'm just going to pass it, right? So, okay. Let's just do it, right? We don't have to, it's the best practices. So I'm just going to say create a function get channel by address, which is basically going to take the path. Then we're going to say create const channels. And then we're going to say, because we're going to use the AsyncAPI parser again to retrieve the channel address. So we're going to say document.channels dot all channels. So now we have the list of channels. So we want to iterate through the list of channels to get the channel based on the path we've provided, right? So what we want to do now is say, we want to do a quick loop. Let's say let I equals 0. So we're going to say I is less than channel's length. And then we're going to say I plus plus. Right? So now what we have to do now is see. So we're going to say if channels at index of I, right, dot address. So if we go through the list of channels we have in our AsyncAPI document, and we are able to find anyone with the current path, the current address, then we want to return the channel, right? So we're going to say that address is equals to the path we are passing here. We're going to say path, right? Console.log the channel address, right? Let's say channels address, right? So now let's call it here by saying get channel address, and then we're going to say path name, right? So now let's call this function, this message validation function. We're going to call it and see if it works. So in order to call it, what we're going to do now is say, so let's just keep this one. Let's comment this one out for now and just call the function. So we're just going to say const message validator. So now we're trying to validate a message. So we say message validator equals to what's the name of what we have here? Message valid. Okay, let's just rename it to avoid confusion. Let's just say WebSocket message, WebSocket validate hook or validation hook. So now we don't have to like be confused. Now WebSocket of validation hook. We're gonna say message validator. Message validator will now be equals to the function, right? WebSocket validation hook, right? And then we pass the socket. So what happens? Let's see. Moment of truth. Let's see if we're gonna get, if it's gonna log the address of the current message channel. So let's go to Postman. Let's connect Mohammed, and now let's see. Let Mohammed send a message. Hello from Mohammed. Did we get what we were expecting? No, right? Because it cannot work because we haven't actually called this message validator, right? And in order to do that, we need to call it inside this code we've commented out, right? So let's uncomment this code back. Oh, sorry. So whenever we receive a message, we want to call this message validator, right? So we're going to say message, or let's just say const is valid message is valid equals to message validator, and then we're going to pass the message. Let's just say just pass the message. So this should work. I mean, message validator. Okay, so it's an asynchronous call function, so we have to await it. So we have to make sure it's like complete before we do it. So now let's save it. Now I'm going to connect again as Mohammed. Connect, and then I'm going to send a message. So let's see if it's going to log the message. Sorry, if it's going to log the channel. So now let's send it, and then it crashes. Right, this is not what we were expecting. So why is it? Okay, so it's failing because we are sending a string, and you cannot do JSON.parse in a string. And that's why we have this, we are catching the error because of we are basically logging it here, right? So we're going to pass an object instead of passing a string. Let's just pass hello. Oh, instead of saying this, so instead of doing JSON.parse of a string, which wouldn't work, I just pass a message, right? So now let's connect. Hello, and send. Right? So we have sent it. So we have an error that says you cannot read properties of undefined URL. Why? So let's see why it says we cannot read that. Okay, so we cannot read that because we passed only message, but we didn't pass the second argument, which is the request parameter, right? So we have to come back to this place and add requests. Now let's save it. Now let's send a message again. Send. So it's not breaking, but we are not getting anything. Let's see if this is working. Get channel address. Let's console.log paths. So okay, so it's passing the whole path name, but what we basically need is only this first one, right? So we need to probably write a logic to extract that away from it, and then only pass what is needed. So what we have to do is basically say, instead of passing the whole path name, we're just gonna say path name dot split, and we're gonna split it by the this question mark, and then we're gonna pass the first index, right? 0. So now let's log it and send a message again. And send it. And then you see it works. So we get the path name, right? So now the path, we're getting the correct path, but then we are supposed to get the channel that address. Why are we not getting it? So, oops. So let me call it again. Let me send a message again. So we are saying channel's name, channels of length, console.log channels dot length. Let's see why it's not working. So we have channels of length, but it's supposed to work, but it's not. So let's try to see. We're saying if channel at index is equals to the path. So let's try to see why. So let's console.log channels at index of I dot address. That's address, not. So postman, connect, send. Okay, it's not working. We are not getting anything, right? So why is it not working? Let's try to see. So let's I equals 0. Oh, my bad. I was using 1 instead of I. That's pretty funny. I mean I, not 1. And I guess that should work now. So let's send a message again from postman. Signed. Now it's working, right? So now we are getting, now we're able to retrieve a channel with that particular address, which is the base part, right? So now it works. So what we want to do now is return the channel ID, right? We're going to say return channel. So return channels at index I. That's the ID, because we're going to use the ID is what we're going to use to validate the message, right? Because if you're using the AsyncAPI validator, you need to specify the message ID. So we're trying to retrieve the message ID logically and not like add coding it there. So because now we can, so in case we have multiple channels, we can retrieve the correct path, right? So now we're going to return the ID. So if you go back to our validation here, if you console.log this channel, so now let's send the message again. So let's connect, we send a message, and now you see I was able to retrieve the message ID, which is the root. Right now, awesome. So what and this is so awesome because I didn't hard code everything. I'm building everything based on my AsyncAPI document. So if I update my AsyncAPI document, my code basically just works, right? My server doesn't break. It just basically updates itself, right? It just works out of the box. So what I have to do now is, so now I have the channels, and what I want to do now is then validate the messages, right? The message I'm getting. So in order to do that, I'm just going to use, so I'm using the AsyncAPI validator. So what I have to do now is say VA, which is AsyncAPI validator, dot validates, right? So I shared the link to the AsyncAPI validator in the comment section. So feel free to check it out. So I'm going to say VA dot validates. So the message, because we have two type of messages. We have the message for connection, and we have the message for chat, right? And then this one, what we are trying to validate here is the chat messages, right? So you can, when a client send a message, we want to validate what kind of message they're sending. Is a message they're sending the standard for what we define our AsyncAPI document? If not, we need to return an error, right? So what we're now doing is now saying chat, which is the message component. Say chat, which is the message name. And then we pass the message, which we are receiving. And then we pass the message, and then the channel, which we just received, the message channel, which we receive, which is the root. And then we then pass the operation, which is send. And that's it. That is it, right? So let's see if it's going to work. Let me drink some coffee. Whew, awesome. So let's see if it's going to work or it's going to break. Moment of truth. Now, let me send a message. I'm connected, so I send a message, hello, and it doesn't work. It returns an error, right? And then the error, it says message identifier is required. So because we're using the AsyncAPI validator to validate our messages, so the AsyncAPI validator requires a message identifier. So if you look at the AsyncAPI documents, AsyncAPI validator document, the AsyncAPI package link I shared in the comment section, you will see why it is required. So what we have to do now is just go back to our AsyncAPI documents. Basically just had just one thing, the message identifier, right? So to do that, we just have to go to our messages. So let's look at our messages. So now we have two messages, right? We have the handshake and we have the chat message, right? And what we're just updating is the chat message, because that is the message we are validating, right? So we just have to pass in the chat message. We just have to pass a unique identifier to the chat message. So in order to do that, just go to the chat, this one here, and then pass X unique ID. Of chat. So that's what we're going to do, because the AsyncAPI validator requires it. So we need to pass, and then we're just basically using the same name, right? The name that is assigned to the AsyncAPI document, which is also the ID. So just have to like pass it there. And then when we go back and we send a message, it would work. Let's restart our server just to avoid so many logs. So now let's connect. Now let's send a message. Did it work? So we have another error. Message identifier is required, but I just passed it, right? So let's see why it's still requesting identifier. Unique ID. Okay, so we have the chat, we have the message, we have the channel. So what does it mean by message identifier is required? Oh, I think it's from here. I think there's a typo where I initialize the WebSocket validation. I thought as much. So there was a typo here, so I need to fix it, and it should work. So let's go back to Postman and connect, and then send. Now it works. Awesome. But then look at what happened. So when I sent a message, I was basically sending a normal message, hello, but then it told me it returned an error, right? Now let's look at the error. And then the error is this. So it says data must be object, data must be object, data must be object, data must match exactly one of the schema. Right. I mean, it's so awesome because the AsyncAPI validator already does this. So if I'm passing a normal string, it's basically just going to validate the message the client is sending against my AsyncAPI schema, right? And then it doesn't work because I'm basically sending a normal string, and that would not work, and that would result into an error. So what we want to do now, I mean, we don't want to pass all of these errors to the client, so we need to like do something about that. So when we catch an error here, so what we just want to do is, instead of passing this whole thing, we just want to say sockets send. Hey Tuli, hi. Yeah. I'm still here. I'm enjoying it. See here, I made almost like 5 hours on this stream, but I'm almost done, Tuli. Thanks for checking. I mean, it's Friday, so I just thought, well, what would be the better way to enjoy my weekend, right, than to do a live stream? So now, awesome. So what we have to do now is, instead of logging this whole thing, we cannot send this whole huge, enormous amount of errors to our client. So we need to like send a better one, right? So what we want to do now is say socket.send JSON.stringify. Oh, oops, so socket.send JSON.stringify. We're going to say, so we are going to use the same things we've been using, the same message type we're using for chats to send errors back to users. So we're going to say type error, and then we're going to say, let's say text error.message. And then we're going to return we're going to add the timestamp of the error, the time when the error was sent back, timestamp, and then we're going to say new date, not it's a string, right? So we're going to say this, and then we're going to say when we return it, we're going to say return false. So if it is true, if it is validate, we want to return true, because I mean we need to return it because we are using it here. Here is valid, right? So if it is true, it works. If it is false, it fails. So now we're gonna say if it is valid, I mean if the message we are sending is valid. So we're gonna say if is valid. I mean, so if the message after the whole validation has been done, if it is true, then we want to continue, right? If it is false, we want to send the message back. So what we want to do now is, if it is true, we want to broadcast the message. So if we are sending a valid message, we want to send the message to the rest of the connected clients, right? Which is the last part of our server, right? So what we want to do now is say, so if the message is valid, we want to send message to the rest of the client, right? If it is false, then of course we're going to send it to the client, to the errors. Like we're going to send the error back to the client, which we are already handling here, right? We're already sending it back. So what we want to do now is broadcast the message if the message is valid. But we haven't done, like, we don't have any broadcast function, so we just have to like include the broadcast method to our AsyncAPI file. To our server, right? To the WebSocket manager, yeah. So now we just have to come here after the remove connection or before the remove connection, anywhere you can put it anywhere. So we're just going to say broadcast message, right? And to broadcast message, you just have to do here, we're going to say broadcast, right? We're going to say the message and the socket, like the person sending the message, because we don't want to send the message to the person sending the message, right? We only want to send a message to the people connected to the connection to the server, right? We don't want to send message to you that is sending the message. That would suck. So what we want to do now is say eSockets. The socket of the person sending the message, of course. So we're going to say broadcast message. So we're going to say, so we want to go through, we want to go through the list of connected users and only broadcast the message to everyone except the person sending the message. So that's what we want to do. So we're going to say this dot connections dot for each, of course, like for each connection, we want to say, on the socket, and then we want to say, so we're iterating over. We're going to say if the socket, right? So if the current socket we are iterating is equal to the socket of the person sending the message, then we don't want to send the message back to the person, right? So what we want to do is say if socket, okay, instead of saying either, we're going to say sender socket. So if socket is not equals to sender socket, then we want to send broadcast the message, of course. Then we're going to say if socket is not equal to sender socket, we want to check if the socket connection is ready. I mean, is functioning. And then we're going to say and socket dot ready state. I mean, the state of the socket is equals to WebSocket. No, is it no? Not this one. I think it's this WebSocket dot is equal, dot one dot open rather. You see, so open. So which means if the socket, like if the person sending the message is not what am I saying? Sorry. So what I'm trying to say here is if the socket sending the message is not equal to the list of connected sockets, and the socket dot ready state is equal to WebSocket dot open, which means an open instance, like the connection is open, then we want to broadcast the message. So what we're going to say is say socket dot send. I'm going to send it to each and every socket except the person sending the message. So socket dot send, just under stringify message. Oh no, I don't have to do just okay. Just stringify the message. This message that we are sending, message we are broadcasting, right? Message. Awesome. So we have the broadcast function. So we just have to like call this method if our message validation works. So what we just have to do is come to this handler and saying if message is if the message we received from our connected client is valid, then we want to broadcast it, right? So what we're going to say is now say WS manager dot broadcast, right? Because you can check the broadcast takes both the message and the so the message and the sender socket, right? So we're going to say WS manager dot broadcast the message, right? Because we've done the whole validation of the thing, the message and the socket. Whew. Awesome. Now we have written our server. Now let's test it to see if it is working as expected. So I'm going to switch back to Postman in a few seconds. Okay, let me switch back to Postman to see if it's working as we expect it to work. Postman. Awesome. So now we are back at Postman for the moment of truth. Oh, it's been a long session, right? I mean, it's not easy, but it's fun. So what we're gonna do now is say, now we're gonna connect our first user, Mohammed, connection established. Now we're gonna connect our second user. Okay, let's move it side by side. Oh. Okay, so we have our first user, Mohammed. Let's try to connect Mohammed again. I mean, it's not going to work because we have this whole validation thing in place. So let's connect our second user, Mohammed. Let's move Mohammed to Ace. And then let's say the color, now color blue. So now let's connect. So we have two connected users, two connected clients. So now let's send the message that is not valid, right? So hello. So we see, now let's see if Mohammed gets the message. But you see, Mohammed doesn't get the message because the message is not valid. So Mohammed doesn't get the message. But then I get a message back saying, oh, the message you send, like it says error. Come on, what are you saying? So type of error, data or message must be a type of object and stuff. So we get this whole thing saying the message is not valid, right? So if we go back to our AsyncAPI documents, let me go back to Studio real quick to see the kind of message we can send. Let's go to Studio. And now we have back at Studio. Now let's see the kind of message we can send. So if we come to this, so the chat, so this kind of message we can send. So let's see, we can send either this kind of message or this kind of message, right? So let's see. So you can either send a chat or a drawing. So let's try sending a chat, right? So let's go back to VS Code. Now let's go back to Postman. Postman. Okay, we're back at Postman. So now let's send a valid message. Now we're gonna say we're gonna send a message of type chat. Type chat text, which is the message you're sending. Hello, people. Hey, hello, beautiful people. And then the next thing, oh, it's sorry, we need to make it an object. So timestamp. I mean, we don't have to do this on our own. We can just like copy this message. Timestamp. Time of sending the message. And then we pass this, right? And then let's see if it's gonna work. And kaboom, it's worked. Let's say, why is Restream always stopping my screenshot? Awesome. So let's see. So when we send this message, it doesn't work. So let's clear messages. Let's send it. So we get an error saying one schema. I mean, it matches, right? Type charts, it should work. Let's see why it's not working. Type chart, the text, and the timestamp. Oh, so it's not working because in the document it's not chart. It is called text, not chat. So I was using charts instead of text. So when I change this back to text instead of charts, I think that should work. So let's clear our messages and send it again. Oh, come on. It's not still working. Let's see. So it's saying incorrect data type. That's weird. I mean, I think we're sending the right data. Okay, I mean, let's try withdrawing. Or better still, let's just copy one of the examples from the studio. Text. So let's copy this. And then send this. And let's see why it's not working. So we are getting an error. So let's try to investigate this error. Now let's go to VS Code because I mean we are sending the correct data, but it's still validating and saying it's not correct. So let's see why. Let's go back to VS Code. Awesome. So we back to VS Code. Let's see why. Let's add connections to users. So when we send a message, so let's log this. Let's console.log is valid. right? So let's see why it's not, if the message is not valid. So let me try to send a message again. Connect and send. Okay, it's saying the message we are sending is not valid, but I think it is valid. So let's see why it's not valid. So when we go back to the message validator, oops. Okay, go back to the message validator. We pass the channel, we pass the chat. I mean, that's the ID, right? We pass the message and the channel, which is the room, the root channel. And we pass the action of send, of course. And then we pass the chat. So it's saying it's not valid. So let's see why it's not valid. That's weird. Oh, why is it not valid? Come on. So that's the I mean, let's log the message first. Let's see if we actually send the right message. Let's sort of log message. So, okay, let's see. So we are sending the correct message, right? We're sending the message type, drawing position X string, which is valid against. Which is valid against this message. This channel. Now this is interesting. So let me log the error. Let me see why it's saying it's not valid. Because that's a valid message. Oh. Signed. So let's see. A key chart. Message must be an object. This is tricky because we are actually sending an object. So why is it not working? Okay. So let me see this document. We have the chart, and we are saying chart can either take one of drawing or text, right? Which is correct. But it's still somehow validating it as a wrong message. What is this validator doing? Your channel, the message. Now this is really tricky, guys. Let's see. I mean, we're running out of time. We might not be able to implement the client, but I'm gonna share a link to the client. That which is pretty straightforward. So you can give it out. I mean, the important part is the server, right? So uh, I mean, we are sending a valid message. Why is it saying it is invalid? Type of drawing, kind of. Oh, what am I? I'm really confused. Everything seems okay. VA validates charts, message, and then send it. or maybe that is not an error. Or maybe let's drop it and let's pass as JSON. I don't know. JSON the pass. Let's try it again. Connect and sign. Ha! It's it's okay. I mean, it's because I was passing. Okay, why is it not working? I mean, is it passing? Okay, okay. I know why it wasn't working. It's because I was when I was converting this to from buffer to string, so it's still saying message as a string. So when I pass message to the message validator, the AsyncAPI validator is saying the message as a string. So now I have to pass it from a string back to an object. So that was why it wasn't working. So now it works, right? So let's get rid of these logs. That was a close one, actually. So let's go back and get rid of these logs. And then go back to our VS Code. VS Code, right? Oh, I'm sorry, Postman, not VS Code. So now let's connect our clients, Ace, and then let's connect our second client, Mohammed. And then let me send a message. So I'm sending this message, which is a valid message of type of drawing. And let me send it to, and then when I send this message, and when I go to Ace, you can see Mohammed also received the message because it's a valid message, right? So if I send another type of message, I mean, this is the first type, which is drawing. So I can send charts. If I change this to charts, I don't think it's gonna work, right? So because it's not valid against so a type message type of chart isn't expecting this kind of payload. So we have to update it to a valid chart message, which is gonna be text of hello people, and then timestamp. I'm sorry. And then I'm going to say timestamp. And let me just copy the timestamp of this error message. So let's see. Let me clear these and send it. Oh, sorry. So let's connect. Oops, what happened? Oh, our server crashed. Sorry. So let's connect it and then send. And then we see it says invalid because we are sending the wrong type. It's actually text, not chat. And let's send it. And then it works, right? So when we come here and send it again, you see we get the message from the other connected client, which means our server is ready, right? So this is everything. You can see how it was easy to make me, like it was easy for me to build my server based on the AsyncAPI document. And it actually makes my server really, really reliable, right? So if I update anything in my AsyncAPI document, my server would not have to break, right? I just have to, it just works, right? So now that our server is up and running, so what do we want to do now? Should we build the clients? I mean, I feel extra tired, but I still have a little energy to build the clients. We should, I mean, we should do it, right? So now I was not gonna do it before. I mean, we could just spend the next, like, let's say 20 minutes building the clients. So quickly, let's just create. So our server is up and running. Everything is working as expected. Let's get rid of any console.log. Console.log. So now let me switch back to VS Code. And I'm basically going to, so I have my server ready. I'm not going to code it. I'm just going to import it because I have it ready. And then see, it work. On my clients rather, not my server. Where's VS Code? VS Code, VS Code. Come on. Uh-oh. Okay. Okay, now we are back in VS Code. So what I want to do now is implement my clients. So I want to build my clients like communicate with my server. So I have, because I've run out of time, I'm not going to code the client from scratch. So what I'm going to do is import the client and then give you some walkthrough to it. So I'm just going to copy my client from here and then paste it. Right, so we have the client. So basically, I'm just going to close this whole server tab and then open the client. So the client is basically a simple React application that if we come to this, I'm just going to explain it quickly. So I've made sure I had enough comments for you to be able to like walk through the code when you're when you're trying it out. So you can check it out. So it will be easier for you to understand the code. So we have a React application here, and then we have the a state for managing our WebSocket. We have where we set the users. We have the chat message type. We have the message drawing type. So we say if there is a user, right? So if we have a user, then we initialize the WebSocket connection based on the username and the color provided by the user. And then we have all of these that says check if WebSocket was successfully initiated. So if it is not initiated, then we want to like close it. So if it is successfully initiated and it is defined, which means it is working, we got a WebSocket instance back. We want to say we want to listen for incoming messages. So we say what's on message, so pass the incoming messages, right? So we are saying if the message type is an error, like if we get an error back, we want to alert the error. I mean, you can already see all of these happening in Postman. So it's basically just the same flow, right? It's the same thing, but this time just how we're writing the code. Yeah, so if it is not an error, then we want to set the state of the WebSocket and then alert the user, which is the message we get when we acknowledge the handshake message to acknowledge connection. We want to alert it to the user, and then next thing we're doing is then we say if so render the user modal if no user is set, otherwise render the app component. So if there is no user, so immediately we load our app web client, our application, where what we want to see is the username and the color, where you have to input username and the color, right? And then we have the whole our application wrapper, which basically so we're using context API to manage state. So now we just basically just pass we wrap our both our charts and our Canva, which means our drawing. We wrap it around the provider, the context provider. So, and then we just pass the value, right? We pass the WebSocket instance, we pass the username, the user information, and then we pass the chat message, which is basically when we receive a message, we pass it because we need to also see it on our screen. We'll also pass the join message, right? And then if you go to the component, you can see both the Canva board and the chat application here. So we have everything done already. So we have the whole Canvas setup. Then we just, get this, and the most important part in this our user interface is actually this use effect. So we are saying if we receive a drawing message, which is basically what we are getting from the context here, drawing message. So if the kind of message that is incoming is actually a type of drawing, then we want to insert that particular position on our Canva, right? So we can see where the user is drawing. So we have the draw on canvas, and if you see the draw on canvas function, is basically where we like to do this whole thing, where we set the Canva paths with the line width, the color, which is the most important part, is actually the context of stroke style, right? So we're saying if local, like if I am the one drawing, right, I want it to be black, right? I want to say black. But if it is someone else's that is drawing, I'm receiving someone else's drawing on the Canva, then I want to use the color. I mean, if you've been following, you know how we initially, before you create a connection, we require your username and your color. So this color that you specify is what other clients or other connected clients are going to be seeing on their Canva, right? So that's basically what we're doing. And then we have this whole function where we start drawing and everything on the Canva. So this is just basically using the HTML Canva. Then we set the whole drawing. So this is where this is also an important part. I mean, you've seen it also. I've done the demo already on Postman, so it's basically the same flow. This is where we send our own drawing data, where we draw. So we just say send drawing data, where we said so the same thing. If the WebSocket connection is open, then we want to send our drawing data, right? We say type of drawing, position X that you've seen in our data in our AsyncAPI file. The X, the position Y, the color, user as color, then we are sending our color also to the users, right? So let's see what the UI looks like. Let me just see the into client. So let me just do install real quick, install the necessary packages. Awesome. So what we're going to do now is just run npm run start to load up our client. And I'm going to show you, what's will I go? Awesome. So I'm going to show you what a client's like. Okay, so I'm going to share my screen to the client. Switch. Awesome. So you can see what the client looks like. Now we have all of this user interface to interact with our server API. And then, of course, you know, before we initialize the connection, we need the username and the color. You've seen it when I was using Postman to test our server out. So I need a name. I'm going to say Ace. And then I'm going to say color. I'm going to choose red. And then I'm going to enter. Right now, you see, I get an acknowledgement, which is cool because we have this whole thing working. So, which basically says the number of connection and the connection status, right? Which is 1, right? So let's save it. So what I'm going to do now is initialize a new connection. So I'm going to say localhost 3000, and then I'm going to say Mohammed, because Mohammed, and then I'm going to choose color red. I'm going to enter, and then you see I say number of connection 1, but status of 0. Why? I mean, when we receive status of 0, it means connection is not successful. And the reason why it's not successful is because the color red already exists because I chose red, because and then Mohammed is trying to use red, so it cannot work. Right? So when I click OK, it shouldn't work. No, it shouldn't work. Okay, let's refresh it to make sure we're doing the correct thing. I mean, when I say Ace and I'm saying red, right? 1. So when I say Mohammed, it should be blue, not red. Right now, you see number of connections 2, status 1. Right now, it works. Right. So now, what I can do now is we still need to modify our client a bit. So let's just test it out to see if it is actually working as expected. So now let me try to draw on my Canva and say, now I'm drawing, right? Let's see if Mohammed actually receives this drawing too. So Mohammed is not receiving this drawing. So which means something is wrong, right? So let's quickly try to inspect what is happening. Are we making the right connections? No, right? Because it shouldn't work. Because if we go back to our client, what's our source code? Okay, let me change it back to VS Code. What's the drawing? So let's go back to VS Code. Now, if we go back to our app.js, we are initializing our connection here. Okay, of course, it's working, the username and the color. So why is it not working? So let's see. When we connect, so let's console.log the message to see if we are actually receiving message from the other client, right? Let's say console.log the message. Okay, so I'm gonna close this. I'm gonna refresh this. So I'm gonna open a new client somewhere else. Localhost 3000. Now I'm gonna say open this log. Oh, I'm not sharing my screen. Okay, let me switch back to the browser. Right. So now I have my name is, and I have my color red, and I enter. Right, and then I'm gonna open a new connection in another browser. Let's say Mohammed or Mohammed red. So let's open our log to make sure we are getting a message. Developer tools, right? So Mohammed red, and then let's say Mohammed green. Let's enter. Let's save it, right? So I'm gonna draw on the other browser, and you see for some reason when I'm drawing, I'm not receiving any message here. So let's see why is that. So let's see why we are not receiving any message. Let's go back to VS Code, try to investigate why it's not working, right? So let's see if we are actually making the right connection. Let's say console.log WS. Let's see. Okay, working as expected. I'm gonna say okay, few seconds. Okay, so why are we not getting the message as expected, right? So we have the connection initialized. We have the what's it on message. So let's console log the message in. So anytime there's a new message, we want to see it. So let's refresh it. As color red, enter, connection established. Let's do it again. As Louis blue, connection established. So let's see why it's not working. It should be working. I mean, we have our server functioning. Let's see why it's not working. So let's log in our server. Let's go back to server. Let's go to index.js. So when we send a message on message, so let's see if we are actually getting the message. Console.log message, right? So we should see the message here. So I'm going to log in again as AsyncAPI client. Ace color red, enter. Right. So I'm going to send a message. You see, I'm getting a message, right? So because immediately I start drawing on my board, you can see, which means the messages are getting to the server, but for some reason it's not broadcasting. So let's see why it's not broadcasting. So now let's see if the message we are sending is a valid message. So let's check console.log is valid. I'm going to refresh my browser and log in again. So it's saying it's a valid message, right? And if it is valid, then that basically means it is broadcasting, right? So, but for some reason, I'm not getting the message in my client, in my other client. So which means our server is working as expected, but if for some reason it's our client. So if we say hello, so okay, so let's see why we are not getting it also. So when I use the chat feature on the web app, I'm getting false. And the reason why I'm getting false is because I have to update in my client the chat component to send type of text, not chat, because that's what our server is expecting, right? So if I say hello, now it's working. Now it's true. Now, which means everything is working in our server, but the problem is coming from our client. So let's see if we can investigate this problem. Uh, this we are in the last part, and now we are stuck. Let's try to unstuck ourselves. We're almost done. So messages. We say what's that on message? But we are not getting any message. And we are actually broadcasting it, right? I mean, that's what we are doing in the server. Because if you come to the server here and go to the broadcast, we are saying socket the sign. This is the message. Because if we consider log the message, just to make sure like our server is not a problem, because our server can't be a problem because we are actually following our AsyncAPI document. So let's send hello. So let me refresh the browser. Let me say hey. Let me say red, blue, save, and I send hello. So I see. So the problem is not actually the client. I think the problem is coming from the server. I didn't see that coming. So because when I broadcast the message, so if the message is valid, which is valid, something is wrong here. So let's say message log message. So let's refresh it. Red, enter, send. Okay, so the message is not, the problem is not from the server like I suspected. It's working as expected. So why is it not broadcasting here? So when we log here, okay, we're almost done. I'm just trying to figure out why it's not working, why it's not working on the client. In a few seconds. Okay, we green. And then I'm like, I see. Let's change this to text, not drawing. Let's see if this is where the problem is coming from. Okay, that's not where the problem is coming from. Oh, so sorry. I was logging the wrong parts. Damn, look at me. I should be logging it here when there's WebSocket, right? So I want to log the message here, not the other way. My bad. So let's try it again. A color red, log in. I'm gonna try again. Louis, red, blue. And then when I draw, oh, now, okay, now it's working. So okay, now it's working. So now let's try to see why it's not drawing on the UI. So I'm saying if message type. So I'm saying if this message, right? So I'm saying, So when I log this is working. I'm getting the messages on both hand, which means this is broadcasting, but it's not showing, right? That's just the problem. So I set the chat messages. I set a, so let me inspect it from the chart, right? So I'm saying if there's a chat message, let me console log this chat message to see if I'm going to receive it. So let me reconnect. So I'm not receiving the message on the chat components, but on the app components, oh, on the app components, I'm receiving it. So it means there is a problem where I'm passing the data from parent to child. So let's try to fix that. And we should be done. That's the last part. Message type. Let's see if message is type of text, console.log. True if it is drawing, console.log. False. So let's connect again. Red, connect. Louis, green. And let's see. Hello. I see. So the whole thing is happening from here, from this whole function where I'm checking the message type and setting the states. Oh, okay. So we should be able to resolve it from here. So let's log the message here. Let's see. Because our server is functioning, it's just our client. Why is our client not broadcasting messages? So I'll say, okay. Now let's see. I think this is where the problem is coming from. Let me log this message type to see if it is actually working. I think I figured out why it's not working. Few seconds, Louis, green, and then I'm gonna send again. Haha, I knew it. So the reason why it's not working is because for some reason, this is where the problem is coming from. So when I say this is not pass e.data, it's not working for some reason. And why is that? Because when we send the message in our server, we already stringify it. When we broadcast the message, let's go to the server real quick. So here we already stringified, right? Just under stringify the message, and then in the app, when we receive the message, I'm saying like I'm passing it, right, which is converting it back to a normal object, but for some reason it's not saying it, right? So let me show you what I'm saying. So when I log the message, right? So I'm going to show you my screen. So here, so when I do this, right? So I'm going to show the developer tools. Awesome. So when I do this, so I'm going to create login for my other browser is red, color red. So, and I'm gonna do Mohammed, and I'm gonna assign the color green, and I'm gonna enter. Now look at what happens. So when I send a chat message from my other connected clients saying hello world, right? You see what happens, right? You see I get the data, right? So which is this. But then when I say data.type, it returns undefined, but then there's type. So which basically means what is happening? Why is it returning that a string when I already did JSON.pass? Which is supposed to convert it back to JSON object, right? So for some reason it's not converting back. So let me try to see. Oh, you all can see my terminal. Oh, awesome. So this is what I mean. I cannot share develop. Oh my god, this is crazy. I just realized I cannot share my terminal on Restream for some reason. So just want to basically show you what I'm saying somewhere else. So let me switch back to VS Code. So when I log message, this is what I'm saying, right? Okay. Let me show you what I'm saying. So I'm getting a string like this. So this is what I'm getting, which is really weird. I'm getting it as a string. Like despite the fact that I already passed it to return in typical object, but it just keeps returning as a string. So I'm trying to figure out why it's doing that. So because it's returning as a string, so I don't have access to message.type because then it doesn't exist, right? So let me see why it's doing that. So why is it not passing? Okay, let's see before we pass it. I mean, what do you mean stop sharing? Okay, so what we want to do now is try to figure out why this is not working. Yeah, I tried to show browser console, Mohammed, but it's not working. I mean, I don't know, maybe it's some sort of restriction or something. When I try to share the browser console, Restream is not showing it. It just keeps like shrinking the browser instead of showing the console. So I guess I don't know how to do that. So I'm just trying to figure out why it's not working. So let me try to console.log the e data directly before passing it to see what is returning. This is the final part of the stream, and it seems not to be working. Everything is working like expected in our server. Our server is functioning. Mohammed, and we're gonna say green. I'm gonna enter, and then let me see. Let me send a message. Wow. I mean, it feels like I'm out of option. It's not working. I mean, it's returning a string. This either data is returning a string, of course, because it is stringify. Right? So this is what is that? What just happened? Yeah. So when I log this, I'm getting this. Right? Which is correct because then it's supposed to work. But then when I pass message, I'm saying just not pass either data, and then I'm expecting to return. Exactly. I'm expecting it to return an object, but it's not working. I mean, I've never seen this before. I don't know. It's not working. Where it hasn't been passed. I'm so confused right now. Why is it not passing? Okay, you know what? Let's try something. What if I pass it 2 times? Okay, let's try it. Let's try it. Let's see. Console.log. Console.log. Let's say JSON pass message. So I mean, we never can tell. So let's try. Let's see what happens. I'll say Muhammad. I'm gonna say red. I'm gonna log in. Okay, moment of truth. Oh no! It works. Why did it work? I mean, why do I have to pass it twice for it to work? Okay, let me investigate this. I think probably is how I'm sending the data from the server. I mean, I can stringify it twice, right? So let's just go back to the server. Let's investigate this real quick. So we have a message. So when we send the message, right? Let's see what is happening. Let's see console.log message type to see if it is actually passing as a string or as an object. So let's see. I'm gonna join real quick. So now is color red, enter. Yeah, maybe I'm trying to figure out. So when I say hello, yes, actually, I'm stringifying it twice because you see when I say message or type here, it's not working. So you need to be careful there. So I don't have to say JSON the stringify again because I already did it here in my. So if I go to where I'm validating the message, so the message validator, I'm saying JSON dot pass. Oh, oops. Exactly. I think that's exactly what is happening, Mohammed. So I think it is stringifying it again. So because when I come to these parts of my where I'm broadcasting the message, right, it's already returning the message as a string instead of as an object, right? So I want to be sure if it is Fastify that's doing that, or maybe I'm the one doing that unknowingly. So let's see. So we have this stringify here. So we pass this message here to string, right, which is a string right now. And then I'm saying just not pass the message. So which is supposed to convert the message back to oh. So let's see. So let's try it again. Let's see why if we are the one doing it or it's Fastify has some middleware that's doing that. So let me see the type. So let's see it again. So also undefined because this is what is causing it. But then when I say, okay, just to make it, just to be sure if that is what is causing it. So let me say const a equals JSON the pass the message, right? And then I'm saying console.log the type. So let's see if it's gonna fix it. I mean, it's working. So this is working. So we are passing it. So this is the message validator. we are passing it as an object here, right? I think it's Fastify. We are not the one doing it, but it is working as expected. We are the one doing it. We are the one doing it. So I just figured out how we were doing it. So what happened is when I passed the message after we validated the message, and the message is valid, we have this. When I'm broadcasting the message here, I'm broadcasting the message as a string because this is returning a stringified version, of the message, right? So we are actually the one. It's not Fastify middleware. We are the one doing it. So because this is returning a string, right? It's the stringified version of the object, and then we pass it here stringified. You can see it says message type of string. We pass in a stringified version, and then when we are broadcasting it, we are still stringifying it again. So when we do it, so we are still stringifying it again. See, instead of us to just pass the message, which would fix it. So yeah, it's not falsifying middleware. We are the one, passing it, stringifying it twice, and that's why it's not working. So let's refresh. Let me test it again to make sure it's working. Okay. Let me log in as Mohammed in my other browser. Green. Awesome. So it's working. So now let's go back to our code and fix all the changes we've made here, thinking we were doing the wrong thing. Okay, let's see if this fixes it. Awesome. So it's working. It's so awesome. Mohammed, thank you for the heads up. I mean, you were following through, so you were able to like see we did a mistake. Yeah, Sagar. Yeah, I hope I could pronounce the name correctly. Mohammed Mendy, you sound eligible. Yes, Mohammed. Yeah, you do actually. Thanks for catching that. So cool. Now let's see if it's actually working. Okay, so let's switch back to our browser. Play screen to React. I mean, let's just share the entire browser, right? Awesome. So now what I'm gonna do is try it out. Moment of truth, Mohammed and Sega. And if whoever is live for me, let's see if it's gonna work. Let's see if 5 hours of this stream is not gonna be a waste. Okay, so let's create our first user name red, name A is color red. I enter, right? So let me just close this terminal, and then let's log into another instance. Name Mohammed, color blue. So Mohammed is blue. This is red. So we have two connections, right? So let's send a message. So if I say hello world, now Mohammed is sending a message, right? Saying hello world, right? So let's see if I'm going to receive it. Hello world. Now let's see. Ha! It works. So now the chat application, the chat aspect is working. So let's say hello to you. So let's see if Mohammed is going to receive it also. And then we can see Mohammed received it, right? So the chat aspect is working. Now let's see if the drawing aspect is working. So Mohammed is, I mean, don't forget, I think Ace is red, Mohammed is green, just to be sure. So let's say Mohammed is going to do some drawing. Okay. Okay. I mean, this, I'm trying to like draw, I don't know what I don't know what I'm drawing. So let's see. It's working. So now I can also draw, and let me say I'm gonna put some ears to the Mohammed drawing. So, and you can see, right? So in Mohammed's tab, when Mohammed draws, Mohammed is basically just saying black because, of course, you need to see black because you don't drawing. You're drawing locally, and it's working, right? And then if I go back, I'm gonna see blue because then blue represents the Mohammed's color because Mohammed chose blue, right? And I chose red. So if I do my own drawings and say A and I go back, Mohammed basically see red. Man, so this is basically working. So if you have any question, feel free to ask. I mean, if you have any follow-up questions, feel free to ask. So this is basically our application. So we just built a real-time collaborative drawing application using the WebSocket and AsyncAPI. I mean, it's long. I mean, we used like 5 hours. I mean, but it wasn't boring because I have like folks like Mohammed, Sega, Tuli, and the rest of the people that watched online that joined me and kept me company. It's fun, right? So we have some comments. We have Mohammed should join the stream would be fun. Absolutely. I mean, I'm going to be doing a lot of these streams, and sometimes doing live streams like this can be boring if you're the only one live. So if you want to join me, if you want to be my co-host, if you just want to hang out behind the scene to help me debug when I'm stuck, feel free to reach out to me. Uh, I would love to have you join me, and then we can do this together. I mean, I'm going to be doing a lot of these live streams in the following weeks. I'm going to be doing more of WebSocket. I'm going to be doing other protocols like Kafka, MQTT, MQP, and the rest like that. So it's going to be fun. So if you have any question, feel free to ask me. And you can see we have this application working as expected, and you can see how our server can easily not server, like you can see how our async API document isn't just for documenting the API, our server API. We also used it when building our API, right? We used it to validate our messages. We used to validate the connection payload. We used to do all sort of interesting things, right? We were able to retrieve channels. We were able to like programmatically retrieve channel based on the path, right? And you can do so many things about async API, right? And there's so many interesting things. So if you have any question, feel free to reach out to me. I mean, it's been a fun 5 hours, and yeah. And I also plan, hopefully in 2 weeks, you're gonna see a video that's gonna be made by me where I'm gonna do a whole breakdown of the AsyncAPI document. So I'm gonna explain every single important aspect that is needed for you to create your AsyncAPI document, ranging from channels to operations to messages to schemas, and also interesting things, right? So stay tuned. Uh, and I hope to see you in the next section. So without no further ado, I want to send a special thanks to everyone that is on the stream, that have joined me, that have left, that came back and still met me on this stream. Special out to everyone, special out to Muhammad, and I hope to see you all in the next stream. So, okay, Mohammed, I would love also to see Modelina and generate an action. Absolutely. Come on, I have a lot of stuff in my bucket, right? And it's awesome. If you have if you are an async API user and you would love me to like do a live stream about maybe a specific tool in the async API ecosystem, feel free to reach out to me, let me know. And if you would love to also join me, I mean, it's an open world, it's open source, right? It's open source, baby. So yeah, feel free to join me, feel free to suggest questions. You can reach out to me on LinkedIn, Twitter, or on Slack on this API Slack channel. So, and I hope to see you all in the next stream. And for now, please enjoy your weekend.